Everyone, how do you feel? You tired? No? I see some very lost faces.
They will come.
No problem. Okay, so my name is Andrea. I am a researcher at the National Research Council in Italy. And I'm also a PhD student at the University of Pisa. I technically delivered my thesis. I'm just waiting for the very long Italian bureaucracy to give me my title. So God help us. So as I tell you, I come from Italy, particularly from here. That's Pisa, the one with the Leaning Tower. But I'm originally from the south. There, okay? So no relation to this guy, Baba, right? But anyway, what I do in Pisa is I study something that's called network science. Network science is a very interdisciplinary field of studies. If there's time at the end, we can touch on that. But what we do within our lab, which you can see is pretty diverse in terms of gender, something we're very proud of, is we study the world through the lens of networks. And one of the things you can study through networks is society. So social networks are one of the primary objects of our study, and specifically social media. So your friends on Facebook, if you still use Facebook for some reason, or your interactions with Instagram, TikTok, but also Reddit, Wikipedia, whatever. So wherever you can interact with something, with some content, or with some people online, that's what we're trying to study. And some of us also study semantic networks, which is something very weird that ties networks and language. And today we'll talk about how to collect data from the web. We will see first web scraping, and then how to use APIs, which is a fancy word of, let's say, doing the same thing but in an easier way. I understand that some of you are very tired, and that coding in Python, especially if you've never done it before, can be very tiring, right? So we'll try to keep it as simple as possible. The code for data collection is generally copy and paste. So if you do research, you're probably being taught that plagiarism is wrong, but computer science likes plagiarism. So I will give you some code, and you can just copy and paste it and use it in your own project, and that's totally fine. Or maybe it will need some adapting, which Gemini will help you with, or ChatGPT or Claude or whatever. But it's totally fine, and you don't really need to understand everything. You just need to get the general gist of it. Are you still with me? Yeah, great. So before we go into things, I would like to very briefly know a little bit more about you. So Sumaya told me that there is, most of you are doing political science, right? Can I have a raise of hands? Great, many people. There's also, I guess, a psychology or something? Sociology, great, even better. Sorry, I have a slight preference. Sociology, raise of hands. That's great, that's why you knew. I was told, I think, Islamic sciences. No one here. Oh, there. That's great. Something else?
Literature.
Literature, nice.
Media communication.
That's what I like. Media communication.
Business administration.
What?
Business administration.
Okay. Are you gonna get us rich or?
Yeah.
Okay, that's great. And most of you are from this university, right?
Yeah.
Okay. So is there anyone else from any other university? Just to understand who I'm talking to. You, sir, where are you from?
İstanbul Kalkınma
Okay, that's nice. Someone else?
Bosnia and Herzegovina International University of Sarajevo.
Okay, Sarajevo, nice. Okay. How should I start? So web scraping. Let's start very easy. Not this. This. I don't think I need to tell you. So I don't want you to think that I think you're stupid. I know that you know why the web is important, just so that we are on the same page. Nowadays, the text, whatever text, most of the text, I would say, are first-born digital. So if you work at a company, if you do research, if you do, well, most of the things you do actually, it's very likely that they are first born on a computer and then someone prints them, polluting the environment. And researchers follow their data, so we need to learn how to interact with the web, how to get data from it. But what I would like to start from is that data collection is a methodological choice. So we will see at some point during this class, we will see that data collection is not, okay, I need to get my data and then I do the analysis. Data collection is in some sense a part of research, a part of the analysis itself. Think about if you want to study, I don't know, parliamentary speeches of, I don't know, the EU. Well, we are lucky enough that they are available online, most of them. But let's say that tomorrow only the ones about climate change are available online for some reason. So data collection impacts, so the availability of data impacts what kind of research you can do. But thanks to the web, most of the time, most of the things are online. We just need to learn how to get them. Just so we are on the same page, internet and the web are not the same thing. So internet is physical. It's a series of cables. There are physical cables running underwater there that connect us all. I mean, connect servers, which is a fancy word for computers, all around the world. And the web is just, it's not physical. The web is this network of documents. So websites, okay? Every website is you can think of a website as a document, okay? There's some code in it, there's some images, but it is in fact a document. So what we will do today is interact with these documents and try to get some data from them. Again, the web is a social archive in the sense that it tells us a lot about society, it tells us a lot about who we are, who other people are. Think about how many of you use social media? Raise of hands. Most of you. So if you interact with someone on social media and you've never met them, or maybe just read some of their posts, most of the time, as humans, we make some assumptions, right? We say, okay, this person says this thing, and so it's probably left-leaning. Or this person said this thing, so it's probably someone I don't like. Okay, so we make assumptions about people, but in a way we try to get to know them. This is what we naturally do as humans. That's what social psychology says. That's what they tell me about it. And that's what the web does. The web gives us another window into the world, into other people, into society in general. By the way, just let's get back to me for a second. I tend to move around a lot, so if this stresses you out, tell me and I will sit down. Second thing, I have the worst eyesight, so if you have to ask you to raise your hands in the back, especially wave at me because I can't see very well. And also if I meet you around and I don't say I, again, eyesight. And finally, me and all my colleagues, we are here to help you. So if this is too much, if this is too fast, or if my English is not enough, like it's not clear enough, tell me, Andrea, slow down. Andrea, talk slower. Andrea, say that again. And interrupt me at any time, and we will resume as soon as everyone is on the same page. Questions? No questions. Great. First of all, before going into web scraping, the first question that you should ask yourself, is your data hard to get? How do I know this? How should I know this? Well, there are a lot of people that have put together all their energy to organize a lot of data into a series of archives. So most of these are legal, so we will see only the legal ones. For instance, user-generated data, you all know about Wikipedia. Some people in Italy call it Wikipedia, which is, I don't know. So this is user-generated data. It means that people come together, they discuss, and then they edit this file, this document, which is the Wikipedia page of some topic. And so people get pretty nasty about it, no? I don't know if you ever navigated this kind of Wikipedia discussion. There are some discussion boards, and people are arguing about, this sentence is slightly incorrect, okay? So this is part of the data that you can get from the internet, from the web. But I was told in school that you should not rely on Wikipedia. I disagree. Wikipedia is a very nice resource. Also, Wikipedia, you probably shouldn't, you know this, but you shouldn't cite it in research. But there are, at the bottom, there are a series of links to research papers and other more credible stuff. So that's what you should cite. You could cite. Open government data. Many government, I just discovered that the Turkish one doesn't exist. Sorry about that. But many governments give you free data about their country, about their people. I think, yeah, the other ones do work. I checked them this morning. And it's a nice way of getting some data. Maybe if you're a social scientist, you might be interested in some of that. Statistic institutes, open data aggregators. So what is open data? Open data is basically data that is, someone might kill me if I say this, but open data is data that is available for free, broadly, okay? There are some websites that collect this kind of data. I think Francesco showed you Kaggle yesterday, or something else like these platforms are full of data sets. So I'm not really sure if they contain a lot of text in like letters. Most of the time these are numbers or statistics or things, but maybe you might be interested in that. Google gives some interesting insight. With Google data search, you can understand how much people search for some terms. For instance, during COVID in Italy, one of the top words search that we could see a spike in coronavirus. Makes sense, right? That's Google Trends. And if some of you knows Reddit, I'm sorry, but if some of you knows Reddit, there is a subreddit, which means a forum, a community there, where people ask for data sets, and sometimes they also publish their own there. Some of them have references, some of them are to pay for, but maybe if you don't find anything else there, maybe you can ask there. And then there are other researchers, other sources, okay? So we will see some of that in a bit. Okay, let's get to it. Web scraping. Web scraping basically is, I have pages on the internet, right? I have documents on the internet. What I want to do is collect data from them. I want to do it in a way that is, I would say, as easy as possible, as reproducible as possible, and depending on what my data is, I want it to be automated, okay? I don't want to physically copy and paste 100 documents in my Word file. I want the machine to automate this task for me. So if you just have to collect 1 or 2 pages, well, it takes longer to write the code or to run the code. So you're better with copy and paste. But imagine you need 10,000 documents or even 100, okay? So that's what you want to do. You want to use some of the techniques that we see today to go and collect data from the web. Sorry about that. Okay. Again, just so that we are on the same page. Browsers. A browser is the software that you use to interact with the web. So it is a software application, which means it's something that is on your computer and you can run. And it allows you to three things: access a website, view it, which means actually seeing it on the, so accessing is like entering a room. Viewing is looking around you, okay? And then navigate it. Navigate it means interacting with it, like changing the page, submitting a form, something like that. So that's, you know these icons, most of them probably. So this is what actually allows us to work with it, with the web. So part of these images were generated with ChatGPT. So if that upsets you, I'm sorry, but I think that AI now has gotten to a stage where some of the infographics are cool. So I'm going to use them. So what does a browser do? So what you do is you write some query. You say, I want to go to Google. I want to go to, I don't know, the university website. What you do is you type the URL. So what is it? It's IHU, something like that, .edu.tr, something like that. What the browser does is, okay, I know that you're asking me for a website. Let me ask the network of computers I'm connected to for that website. Let me find it for you. So it sends what's called a request to the computer that contains the website. Let's get back for 1 second. Every web page is a document. And these documents are physically stored, not physically, but they're stored in some other computer. Every website, even Instagram or whatever, they are documents that exist in some computer. So when you go to Instagram, you're asking Mark Zuckerberg, hey, bro, give me your access to your website. You're asking his computer for access, okay? So that's called a request. So your browser makes that request for you, then that the server, so the computer, Mark Zuckerberg's computer, gives you back what you ask for if you have permission for it, and then your browser renders it, which means it visualizes it for you. And you know, these documents are full of text and some code and some things, and what the browser does is interprets this code for you and renders it visually. Again, a browser is a software that requests data, receives responses, renders content, and hides complexity. There's a lot of stuff that I'm not telling you because it's very, very probably useless to you, but it's a lot of technical details about how the requests are made, the fact that, I don't know, computers don't understand the text, so they understand numbers, so a lot of stuff is hidden from you, okay? But you don't really care about that. Is everyone still with me?
Yes.
That's great. Not this. Again, ChatGPT, but human view versus machine view. You can see that this is wrong here. This should be article like this, but yeah, text with ChatGPT is always like that. So what you see and what your machine see, so what your computer sees, are two different things. Yeah, right, of course. So you see what the browser already rendered for you, what it interpreted for you, in a way that is visually appealing, especially if it is a commercial product. These companies now want you to have like punchy colors or something that attracts your attention, and definitely not some code. But sometimes where something doesn't work, you see this kind of code somewhere. this is what the machines see. And what the machines are good, and you've seen this with Python, they're good with repetitive things, structure, some kind of regularity. And we're going to use that. There is some structure, there is some regularity in the web pages, and we're going to use that to actually, interact and collect data from it. God, you just learned Python and I'm hitting you with another programming language. So everything, you don't have to learn this, by the way, so relax. Everything on the web is written in a language that's called HTML. No need to know what it means. HTML is it's not programming, it's called a markup language. ML stands for markup language. It means it labels content on your web page. So let's look here. Ignore the top part for a second. Welcome to my page, okay? And this is surrounded by H1, and this is the same with this slash here. So this welcome to my page is in this two tag, within these two tags, this is called a header. That's why H1. P stands for paragraph, for instance. So this is a paragraph. This is a simple paragraph this is actually the text that you see. Here it is image. And this is all enclosed in this tag that's called body. And the whole document is HTML. So you see, the various parts of the website are tagged with this kind of structure. Anything, titles, paragraph, link sections, whatever you see, everything that you see on the web is this. So when you code a website, you won't, but the programmers that code website, you write this thing. And nowadays they don't even write this. There are other programs that do that for them. Lazy computer scientists. So this is the page as your browser shows it. So this is what the old computer scientists used to write. And then the browser sees, okay, that's a H1 tag. So I'm going to render it as a big, large text. Then there is a paragraph, so I'm going to render it as text. And then there is a very cute dog image I found on Google. Again, no need to learn about this. Python is already enough. But why I'm not also stressing about learning about this is there is a very good tutorial for it in case you need it. It's called W3 School, the World Wide Web Schools. So this website, I think they're affiliated with the people who created the HTML standard and the web. So what they do is they tell you, or you can Google it, they tell you what these tags do, when you should use them. If you really want to learn HTML, which I don't recommend you do, there are some courses if you want to get into, I don't know, web programming, something like that. But yeah, the basic idea is you have some basic structure like HTML. You can use text for headings, paragraphs, bullet list. Links in media have their own tag. And again, every tag, every tag has an opening tag and a closing tag. Okay, so you see, sometimes when you read this kind of code, it's easy to see where it starts, but not where the tag ends, because they get nested a lot. In a very complex page, it's hard to navigate. That's a very cute dog. So again, lists, layouts, so these are another way of grouping content, and then tables. So yesterday you saw pandas. There is some kind of trick you can do in pandas, where if there is a table in your website, you take the website, you paste it into pandas, and pandas will get the table for you. So this is a very simple way of doing some kind of web scraping, but pandas does it for you. And it does it with the techniques that I will show you today, but it does it for you. So you don't really need to, learn everything in detail. Requests and responses. Again, ChatGPT. So I was talking about requesting a web page, getting it, rendering it. Just to get back to it, imagine you want to ask for some spaghetti. Don't break them when you cook them, by the way, please. Italian grandmas will die. I want to go. Okay. I mean, if you like ketchup on your pasta, I don't judge you. As long as you don't put pineapple on pizza. By the way, sorry, that's Italians get very sensitive. So you want something, okay? And that's exactly like ordering spaghetti. I want to get to that web page. I want to see my university web page. So the browser, which is the waiter, sends a request. It goes to, again, Mark Zuckerberg computer, which is the kitchen, and says, oh, the guy wants spaghetti. So the kitchen gives it to the browser, and the browser gives it to you. Okay? So this is what's happening under the hood. So this is a very simple concept, status codes, but usually people freak out. I don't know why, but this is, believe me, this is very easy. The browser and you, by extension, need to know if something is going well, okay? You need to know if the page you requested can be given to you, or if you don't find it, okay? So under the hood, the browser is asking the server, okay, can you give me that? Can you give me that web page so that I can render it for the user? And if everything goes well, we have what's called a 200 status code. So the server, the cook, gives the waiter the spaghetti, and it just needs to learn some of them. But I'm guessing that you know already one of them, which is 404, a page not found. Document, I could not find it. That doesn't mean it doesn't exist. It means I could not find it. Maybe you are not connected to the internet. Maybe the page is not available yet. Maybe, I don't know, a lot of things can happen. And the other one is you don't have access. Access forbidden. You're asking for a cappuccino after 11? In Italy you don't do that. So access forbidden. You don't have permission. So you don't have, maybe you need some password, or maybe you need your computer to be authorized to do that operation, to access the web page. For instance, if you're a student, you cannot log in to the page where professors, I don't know, upload content and upload content yourself. No? Because there are some users that have some roles. So I can upload this presentation on the Google Drive, and you cannot modify it, okay? Because you don't have access. So this is a similar concept. Everyone still with me?
Of course.
That's great. Robot 16. Okay. So we have to be polite in the way we ask things. Well, not us, our browsers, but by extension or code. By the way, the fact that I'm moving is giving you a problem with the camera? Do you have a problem with the camera? Because I see that sometimes you... Okay. No, sorry. We need to be polite with the requests that we make. Imagine, like when I was younger, I used to go to my mother, Mom, I want to play, I want to eat, I want to do, okay. So she got pretty stressed. And computers do that too. So the easiest way to, maybe shouldn't say this, but the easiest way to kill a computer is to send too many requests. So if you go to a website imagine you have 100 computers. You go to the website of your favorite shop in Istanbul, and all of these computers connect to that website and start clicking around. They're sending a lot of requests. Give me this, give me that, show me that. And maybe that computer that contains the web page is not strong enough because it doesn't expect so many requests. And so it cannot give them to you. That's called in what computer scientists call DDoS attack. If you've seen the TV series Mr. Robot, that's what they do. They send so many requests to these computers, and then the computer simply shuts down because it cannot accommodate so many requests. So we came up with a way to, let's say, set some expectations. Every website, most of the websites, have this file. Again, websites are documents, and there are sets of documents. So they have multiple pages and also some things you can't see or usually don't look for. There is, most of the website, you can go to this robots.txt. So if you get to the facebook.com/robots.txt, you will see, it's a bit technical, but you will see which kind of pages Facebook expects machine to request automatically. So this is not enforcing some rule. If you do something that Facebook doesn't like, first of all, I'm happy because I don't like Facebook. And the second thing is Facebook can't really do much. So it's just a way of saying, okay, automated bots, automated, so web scraping, what your Python program should not go here, should not go there. But I'm fine if instead it gets this data, okay? So again, it's important to be polite with your server, unless that's Facebook. And again, it doesn't stop bots, but it communicates expectation. Finally, what's possible, what's ethical, and what's legal are three very different things. So with computers, you can do a lot of stuff. And collecting data, I mean, if you're very good, so today we will see very basic strategies that are good for 90% of the cases, I would say. But if, you know, now there are some pages that change dynamically. You look at the page, and as you look at the page, it changes. There is some image, some slideshow images that change. So those things can be harder to collect automatically. But you can do it. If it's on the web, it can be collected. Let me repeat that again. If it's on the web, it can be collected. Everything good, unless, so, you know, my father is has a very strong opinions about everything, okay? Especially sports and immigrants, but mostly sports, okay? So he comments a lot on Facebook about he enjoys Juve, Italian football team, and he comments a lot around Facebook with this, today the team was great and this team sucked. Sorry, maybe I shouldn't say bad words. So what happened is, since it's on the web, it can be collected. So some automated software collected that post and sent it to a lawyer. And my father got sued. So if it happened to my father, it can happen to you. So please be polite on the web. So everything that, let me say that again. If it's on the web, it can be collected, whether you know it or not. My father knows it, but imagine you send some picture to someone. WhatsApp is not really the web, but if it's on the web, it can be collected. Whatever you do online, social media, you're sending this, you're saying something to something to someone. Please don't say that to anyone. They're screenshotting it. Everything is online, okay? If it is online, I can collect it and I can collect it very easily with Python. So this is technically possible. Everything is technically possible. Most of the uses that I mentioned are not ethical. And I guarantee that most of the companies, like imagine ChatGPT, OpenAI, who owns ChatGPT, Meta, who owns Llama, Anthropic owns Claude, these are all big AI companies. How did they get these models? Well, they collected a lot of data from the internet. And most of this data they could not have access to. So if you look around, there is, for instance, the New York Times claims that they stole a lot of newspaper articles from the New York Times to train these models. If it's on the web, it can be collected. I mean, it's technically possible. It's not legal, probably, in the US, and it's definitely not ethical for me. And I think, like, this is strictly an opinion. If you're doing research, I'm willing to close my eyes, okay? But most universities, most research centers have what's called an ethical board. So if you're doing a large scale means millions or hundreds of thousands or thousands of posts or things on the web, you should submit your request to the ethical board. Explain things very clearly, very plainly. Most of the people there, sometimes they don't understand the web. So most of researchers have to communicate what they want to do with their data and where they will store it. There are also some legal requirements. But again, in theory, the things I'm showing you today can be used to do something very legal or very unethical, but so please try not to do that. And then APIs. So you notice I'm going very fast. So if something is unclear, if you have any questions, again, if you have questions, wave, because I can't see. No questions? No. That's great. Wow, I didn't expect that. Okay, so what web scraping means is, again, my browser or my code visits a website, reads the HTML code, and I tell him, okay, my image is in this tag, in this position in the page, collect it for me. Then go to this other website, which has the same structure, I don't know, and go to this and take it and collect it for me. The way this is done is by exploiting the regularities of the HTML, right? So HTML is structured. The websites have this thing where if you go to the university website, it usually has the same layout. Typically has a bar at the top with home, students, third mission, projects, something like that. Then there is some images, then there is some other content, something like that. And the university website, all these pages have this kind of same structure. So I can navigate through this with Python, with web scraping, expecting that the structure of the page is similar, okay? But imagine sometimes the IT department goes crazy and decides to change the website. Yes?
So the question says, when you do the scraping, you only look at HTML, or is it capable of reading JavaScript, applets, CSS, PHP, all of these other jargons?
Okay, so your colleague here is asking, so there are a lot of other codes, other languages that are involved in the web. One of these is CSS. It's called cascading style sheets. Basically, HTML provides the structure, CSS provides the visuals, okay, the colors, the fonts, the sizes, everything else, okay? And there's also some other languages that you don't need to know about. What your colleague is asking me is whether these things, these other languages, or what these languages do, I can interact with them with web scraping? In principle, yes. So you can ask your code to collect, let's go back to this. I can ask my code to visit all the pages in a list and collect all the H1 tags. Okay, so this is pure HTML. This is the most basic things that we will see. Go to this page. If you see an HTML tag, I want the content of that tag. So this is a very simplified example, but what you will see is that HTML tags sometimes have other characters in it that are not really HTML, they're CSS. And so you can say, give me all the headers tag that also are red in color. Because maybe you know that that particular content is written in the red color. Or give me all the paragraph tags that are tagged with the word blah, blah, blah, something. So what web scraping allows you to do is read all this and then filter out something, or try to restrict your analysis to specifically what you want to do. So I will scare you for a second. Let me scare you for a second. So imagine I want to go to the Ibn Haldun University. Did I write that correct? Yes. So this is the website of this university. And
Can you make it faster when you're working on?
What?
Can you make it faster when you're working on?
What do you mean?
Like it's taking so much time to work on.
So this is not something that depends on me or on you. It depends on the computer where this page is stored. So sometimes, that's a bummer. So let's go to the University of Pisa. But it's also a problem of my computer. Sometimes it doesn't like to connect to the internet, so I don't want to blame the Ibn Haldun University. So I'm sure that your university is great. My university is not so great, but we're going to see its website. And sorry about that. And as you can see, first of all, there are a lot of moving things here, okay? So let me show you better. So this is the University of Pisa website, and you only see what the browser renders for you. But there is HTML code inside. So now I will tell you how to read it, because you, of course, you need to know which information you want to. So for instance, if I want to get this sentence here, degree courses, sentence, phrase, I need to know where it is in the page, which kind of HTML code contains it. Is it in a H1, H2, paragraph? It's not that hard, it just takes some getting used to it, okay? And how do I read the HTML code? So my browser is in Italian, sorry about that, but in English it's very easy. So you right-click on the page, anywhere on the page, and the last thing should be this inspect. In Italian it's ispeziona, but it's inspect, something that, and then this is where it scares you, because that's HTML for you. So what most browsers do that. For instance, I want this, degree courses. I can't read very well. So you move your cursor through the thing until it highlights what you want. So degree courses is probably here. So this is nested, no? So I want to open it and see, okay. Now we're closer. Let's open it again. Now we're closer. So again, it takes time. Sometimes you need, but now we are already, now I know that if there is this div tag, no, what is it? Tag with class elementor element, blah, blah, blah, blah, blah, blah, with this data ID. I don't know. You know, you see these kind of things, you write it down, and then you paste it into your code and say, okay, go to the University of Pisa website. Go to this page and collect data. Okay, so this is probably not the best example because, I mean, probably the other pages of the University of Pisa don't have degree courses or this thing. This is just the home page. But if you go to basically whatever website that has multiple pages, for instance, if you like, let's say music, okay, there are pages that have lyrics for your favorite songs, okay, so you go, you take your favorite artist, and there is a list of pages with the song titles. You click on a page and it shows you the lyrics. Let's say I want to collect all the lyrics, so all the text of the songs. I just need to understand where the text is on one page, and then I can assume all the other pages are the same structure. So let's say all the text of the songs is in this tag called P paragraph, and they have this CSS, so this color, they have this font, or they have this ID, something. There is something that distinguishes them. So the first part, probably really the hardest part, is to understand where the content is on the page. And you might be already thinking, okay, well, 2 days learning Python, and now you're telling me that I have to do this automate, like this thing that, you know, it can be automated, but it requires some human effort. It's really annoying. Like a project I was doing, we were working on video games. We were collecting all the video games published by Nintendo for research purposes, I swear. And there are some web pages that collect this information. You know that people who are into gaming are very obsessed with very little details. So they write a lot of things. There is a lot of details in this web pages. So we were trying to collect automatically the data from this web page that all look the same. So every game had, I don't know, an image at the top, the title, the description, the price in dollars, whatever. And we wanted to collect them. But the content here is so full of things. It's so many things, right? It gets hard. So most of the time, when you want to collect something from the web, well, not most of the time, but you are sure that you can do it this way. There is a simpler way, which we'll see just in a few seconds. But in case that the other one is not available, this is what you have to do. You go to the website, press inspect, look where the content that you want is on the page, and then tell Python, okay, this is my list of websites that I want you to visit. Or maybe you do it programmatically. You say, okay, this is page 1, then go to page 2, 3, 4, 5, 6, and so on and so forth. And in every page, you collect the things that have the same structure, blah, blah, blah, what we talked about. So this is actually, where is it? Okay. So this is actually what data collection from the web is like. It's a bit boring, I get it. But there is a simpler way. So the technology behind it is the same. Someone sends a request, someone sends a response, browsers elaborate everything, or if it's not the browser, it's Python. But sorry about that, the technology is the same. So there is another thing we will talk about. It's called an API. An API is Application Programming Interface. You don't need to learn that. But an API is basically a standard that someone built to make this kind of requesting data from some platform easier. What does it mean? Let me get to the point. Imagine you want to collect data from Twitter. Well, you can't do that anymore. But if you want to collect data from, I don't know, LinkedIn or some service, TikTok, only social media come to mind to me because I work with them, but BBC, okay, something like that. You can write the code in a way and say, like BBC, for instance, says, okay, when someone wants to collect data from my articles, they don't need to scrape the web. They just need to ask me. They ask me in a way, and I will give it to them. No problem. And how will they ask? They will ask with an API. Again, this is a copy-paste from a course to computer scientists. You don't really probably need to understand what this means. But what the API does is it simplifies access to the data that a website contains. And it simplifies it because there is probably someone that first coded this API, the rules to communicate, to ask for these pages. I don't know if you've ever seen this format before, but sometimes if your page doesn't load well, you see that the content of the page is rendered in this kind of, looks like a Python dictionary.
Yes.
Exactly. So why do we have Python dictionaries? We have Python dictionaries to handle also this kind of structure here, which is mostly how requests and responses are made. So if I want to go to the Facebook website, I will send a request that has, for instance, here as a key has a user, and the value is Andrea, or my computer address. Wants to go to facebook.com, and so it is encoded here as well. Okay, so this is a very, I would say, efficient way to take this data of your request, send it to the server, and then the server, what do? They write another Python dictionary, something like that, and they send it back to the browser. So this is what's normally happening when you ask data for. And this is done through an API. Everyone still with me? Any questions? Too fast, too slow, too boring, the jokes are not funny? Okay, great. So very complicated image. Let's skip that for a second. Sometimes when you look at the URLs, you see that there is this kind of HTTP. You've seen that somewhere. You don't need to learn what it means. It's a protocol, which means a set of rules that someone decided. You can guess that person that decided it is American, probably. It's a standard of how we communicate on the web, how machines mostly communicate on the web. I want to, what do I want to do with the web? I want to get some data. That's what we will be working on with collecting data, no? Getting something from the server. Post data, so if you compile like, a Google form online, or you type in something and you send it somewhere, that's a post action. A put is when you update data. Maybe you change your bio on social media, something like that, or the details of your university, your personal profile on your university website. And delete is you remove data. There are a lot of other things you don't really need to learn about that. Just think about the get thing, the get action method. So what happens is, wow, there are a lot of definitions on this page. What happens in this kind of structure here, when I send a request and I get a response, is the API or someone in this process, what they do is they look at these things. The endpoint, again, just to have a broad, if you don't get it, it's fine. It's just to have a broad idea of what this does. So the endpoint is basically a way to access the content, the data that Facebook owns. Okay, it's basically a door. Okay, the endpoint, the door. When I send a request, the browser sends a request. It says, okay, my user wants to go to that door. That's the endpoint. And to tell it's this user and from this computer, from this address, this request have to have headers. We will see what that means. Headers means some metadata. So for instance, the person who wants to get there, to get to that door, is this person, and the request is coming from Turkey, for instance. And then there are some parameters. So you're asking for the second web page of a list. Or when you go to Google, you scroll down, you end the results, you finish the results, and then you want to get to the next page. So you request with an additional parameter that is, I don't want to page 1, I want page 2. Something like that. And then the body, when you post something, you also, of course, implicitly what the browser does is it takes your text that you typed in your visual interface and it puts it into this body component. And again, think about it as a JSON, as a Python dictionary. A JSON is basically a text that is organized like a Python dictionary. But you can think of it as the same thing. So what the API does is an interface between the users, the browsers that do the stuff, and the database, so where the data is stored. Imagine social media companies have very large places where they store a lot of computers because they need to store hard drives, because they need to store all the data that you post. Every time my father complains about the outcome of a match. Okay? So if you want to access that data, but that doesn't mean with Python. Also on the browser, if you scroll through your phone, what your application does is it sends a lot of requests. Okay? It sends requests, and it does it with the API. Doing it with web scraping would mean that if Facebook changed the structure of something, that would break. So there was a case where, it was a legal case, where some people tried to collect a lot of data from LinkedIn. They were trying to build, I think, an automated job search thing, which could be useful, right? But what they tried to do is scrape a lot of it. They didn't care about the robots.txt file, and LinkedIn noticed. So they found a loophole in the law or something, and what they did is they brought the guy to court, or the guys, I don't really know. I think it was another company. And what happened is, so LinkedIn won because, of course, big tech company. But what happened is now LinkedIn updates its HTML every week so that you cannot scrape from there. Or I mean, if you want to scrape from there, you have to update your code every week. So imagine you're building something as what did I say before? The recommender for new job alerts, something like that. Well, if you want to build that, you cannot do it in the long term. It has to work on 1 week and then until LinkedIn changes its structure. Just think about our example from before, where we had this. If instead of H1 I say H2, which means slightly smaller text, code breaks. You don't get anything. There is no H1 tag in that page anymore. That's what LinkedIn does. Okay, everyone on the same page? Questions? Again, wave. Great. Hope everything is clear. Let me look at the time. Okay, we have some time. Let's bring everything and compare everything together. So web scraping, let's look at the top line. Web scraping is reading HTML code automatically, parsing it. A parser is something that basically reads through the HTML. APIs are just a way of saying, okay, I want this data from you. Give me in a way that I don't need to scrape your website. So it is more structured in a way that is, of course, think about this. If I want to get data from Facebook, I can scrape Facebook. Facebook changes its structure, my code doesn't work anymore. So I can use an API and say, okay, Facebook, give me 100 posts from today. And Facebook gives them to me, if they want. Maybe tomorrow they don't want to, they say, okay, we don't have an API anymore. You cannot collect data anymore. More on that in a bit. So the structured data is an easier access for you, but gives a lot of power to them. So now we will see what that means. The data format, so the HTML is, I mean, it is structured, but let's say I can structure my page any way I want. My website is different than yours. While the APIs typically have the same structure. They look like a Python dictionary most of the time. So one has high flexibility, the other is very strict, which is a good thing. One is supposed to be like, it's fragile, it can break like LinkedIn, and the other one is stable. So if, like most of the time the APIs are the same, but you can be sure that even if the API changes, the result will always be a Python dictionary. The result of your request will always be a Python dictionary. So if you run your code, 10 days from now, it will probably work again. So in one case, you have clear rules. In the other ones, there are no rules. It's the Far West. Okay. Of course, an API needs to be provided. If you don't have an API, you cannot do API access. So I started my PhD in 2022, and I wanted to study a lot of things about social media. You know what happened in 2022? Twitter said, go to hell, I don't want to give you my data. So what they did is basically, first they blocked access to their API, and then when Musk took over, they said, you know what? I'm gonna make a lot of money out of it. So now if you want to get data from Twitter, and somebody of you asked me, can I get my data from Twitter? No, unless you're very rich. I mean, probably some of you are, I don't know. But it gets very expensive. It gets very expensive. And again, data collection is a methodological choice. It impacts the findings. It impacts the research. And Twitter is, I mean, I think it's one of the most populated social media that still uses text. So it's been a big problem. If the API is not provided, I cannot use API. And also Twitter is very smart. So scraping from Twitter is still possible. It's not, I would say that they will do anything to stop you. I mean, they will not physically come here and stop you, but they will try to stop you. There are some systems that detect that you are a bot, that your Python code is collecting the data for you. Sometimes what some programmers do is they write web scraping, so no API, web scraping code. So they parse HTML, blah, blah, blah. And they do it in a way that the behavior, it seems like it's a human. So let me clarify what that means. Imagine you have, you want to collect all the speeches from the UN, United Nations. And you find a website that has a page. Every page is a speech. So you can go through all the pages and your code do it for you. Computers are very fast. You can collect 500 pages in 1 second if your internet is good. Humans can't do that. So if I were a very bad person, I would say, that's my server registered at this address, asked 500 pages of my website in 1 second. That has to be a bot. So what some computer scientists do is, we go to one page, wait a second, maybe go back to the other one, then go to the next one, then scroll down, then scroll up again, and of course, make some mistakes, great. And of course, this takes a lot of more time, but it's still, it's a lot of time that you can do the dishes in the meantime, okay? So your computer does the work, it just takes longer. But when you want to collect tweets, for instance, well, you probably want a lot of them. And so it takes a lot of time, or a lot of machines, a lot of computers doing the same thing. But again, if 100 computers went to Twitter today, from here, and started to collect data programmatically, Twitter will spot you. X, sorry about that. They will spot you. So again, APIs allows you to do a lot of stuff very easily, but it needs to be provided, it needs to be free, unless your institution is very rich. So why do they use API? Let me check the time. Ooh, okay. An API is not something to collect data. Your application on your mobile phone, the browser, whatever you're using to interact with most services, nowadays has an API. It is a way of automating tasks without recurring to HTML. HTML can be buggy, it's hard to read because you need to elaborate all of it. So imagine a machine that has to read through 100,000 lines of text versus reading only one. So computers are fast, but if we can do less work, they will do that. And of course, what sends you, for instance, notifications? Notifications on your mobile phone are done through an API. Those that are connected to the internet, at least. And so, of course, also data collection. There are a lot of things. These APIs are everywhere. We just don't know about it. Sorry. So, what I'm going to get a bit conspiracist right now, okay? So what the platforms do, at least the very big ones, is they want to control your access. I don't mean that in a bad way. Of course, they do that because if you send 100,000 requests, their computers will shut down for everyone. So this happened to the University of Pisa website. Some hackers, they found a way of connecting to the website so many times that I could not register for my exam. So we had to physically go to the university, and well, it was painful. Okay, so the platforms want an API to control access, who can get data, which kind of data can they get. Note that, which kind of data can they get. Not all data is always available. For instance, Twitter, when they had a free API, they allowed you to get posts but not likes. You could only say, okay, this post had 100 likes. Who liked the post? I don't know. Twitter knows, but they don't tell you. Now, don't tell you even if you pay. And then they want to monitor, okay? What happens? This can be done for a variety of reasons. Imagine I once worked with a government in the Middle East where they wanted to prevent or to be very quick when responding to natural emergencies, like earthquake or something like that. So what they ask us to do is basically monitor Twitter, monitor posts online for the word earthquake, or for the word something like that. So you want APIs also to do good things. So we monitor, and these companies do that as well. Think about people who said very nasty stuff on social media. There is something that's called moderation. Moderation is deleting posts that offend people, racist slurs, my father complaining about the outcome again. So this monitoring it can be a good thing. And also there's this governance of research. I mean, as a researcher, you have probably more rights than regular users, because most of us agree that research is a good thing, and it advances humanity towards whatever goal we are trying to reach. So they will technically probably give you more access to data. Some countries, or for instance the EU, require these companies to do that. So in the EU, in theory, because that's not true, in theory, in the EU, the company, the Twitter should provide free access to researchers. Twitter says no, and nothing happens because the EU is like that, but whatever. So again, someone is going to kill me after. I know I get very emotional about these things, so I hope I didn't offend anyone. Again, access to this data requires some kind of developer access. We will see how to collect data with the API. But probably the most time we will spend is not on writing code or executing code, it's in requesting access. Which means if I want to collect data from YouTube, I have to go to a website in Google's server and say, okay, I am Andrea, I am physically type text. I am a researcher at the National Research Council of Italy. I'm doing a research on in the field of political science, and I want to study opinion polarization about climate change. And so I need the data from YouTube to support my claims, to do my analysis, blah, blah, blah. That gives you, this is what most of the effort has to go through. TikTok is like that as well. Nowadays, all the young people are using TikToks, which make me feel very old, because I really don't know how that works. But TikTok's API is very fast, gives you access to a lot of data. But first, you cannot download it to your computer. So you use it in something that's like Google Colab. So it's not physically on your computer. It's in their servers, and you just Colab interacts with it. You need to ask for permission to use that data. You have to declare that you will only use that data for that specific purpose. And after a month, TikTok deletes it anyway. So from the time you get your access, you have 1 month or 2, I don't remember, to do your work. And that, of course, kills reproducibility of research findings. Like Franco, I don't like timelines. But sometimes. There was a time, I sound like my grandfather. There was a time where APIs were open, which means they were free, which means most of them gave you access for free. But then, you know, Facebook, Cambridge Analytica, they discovered that there was some collusion with some parties involved in the US elections, and that Facebook had helped profile users and serve them targeted advertisement to manipulate the election. And that's not the only time that's happened. And that's not the only country that's happened in. Facebook and Instagram, for those of you who want to collect data from those, so Facebook and Instagram have the strictest policies it's basically impossible. Like, I strongly discourage you to try and get data from there legally. I'll say legally, but legally it's very hard. And then what happened is APIs became products. As I was saying, 21, 22, people realized, so this is the 2022 is when ChatGPT was launched, okay? So people realized, someone made a lot of money by giving a machine a lot of text. What can I do? I wonder. I can collect the same data and make my own machine, my own ChatGPT. Well, first that's what they did. So the websites, the social media platforms, for instance, they figured, okay, data is it's the new oil, okay? It's very important right now. So let's make the people pay for it. So that's why now APIs are very expensive. Twitter, extremely high pricing. Reddit has a paid API. It also has a free access tier, but it's very limited. But there are some workarounds. We'll talk about that after the break. And nowadays, there is this kind of a very nasty situation where APIs are limited. So why am I talking about them? What's the point? Well, it is still possible. Some platforms still allow you to do that. We will see some of those. What you need to keep in mind is that some platforms are more lenient. Lenient, is that a word? Like they allow you to get more data. Some allow you to do, 10 requests per day, something like that. Every platform that has an API should have a page where it says, okay, I expect that you do at most 10 requests per day, or 10 requests per minute, more likely. I expect that you collect this data at this rhythm, something like that. And it's hard. If you paste the requirements to ChatGPT, ChatGPT will say, okay, this is the code that respects all the requirements. It's not very hard. But yeah, now there is this kind of growth of data brokers. Data brokers are companies that scrape a lot of data with web scraping, because that's still possible if they're smart enough. And then they sell it at a lower price. So that's another option. Again, if you have money, I don't really like that option. So this is what I call the API calypse, which is a kind of a pun. The idea that nowadays access to data in a structured way is getting harder and harder. No, that's not. And I think we can stop here unless you have any questions, or we can discuss during the break. So how was the coffee and the sweets? How good? Great. So before we move on, let me stress another point, that everything you see on the internet can be collected. There is, like I said, there are many interesting people on the internet that they try to, they have this philosophy that everything must be preserved for humanity, for the future. So they kind of like digital historian. Well, digital historians are a different thing, but they try to archive everything, okay? Everything you posted on the internet, they probably have it, okay? There is a very cool website. Let me see, I can't see very well. It's this one. It's called the Wayback, not working? Yeah, the Wayback Machine. So what happens here is someone at some point collected most of the web pages on the internet at multiple points in time. So if your favorite bus company today, you have to take the bus and it doesn't work, the website, you don't know, you can't read the timesheet. Probably if the timesheet is the same as last year, you can go to the Wayback Machine and load the web page from there. What this means is you can see how the Ibn Haldun University website looks, even if we couldn't access it today. And this means potentially historical research, digital, the history of web pages. For instance, let me look for, Ibn Haldun. It's ihu.edu.tr, right? So you see that this is all the times that this page was collected. Okay, so we can go back to 2018 and see how it looked at this point in time, multiple times a day. Look at that. So this could be, so now not even this is working. Yeah. But yeah, again, even if it's not available today, so now this is not very good to look at, but even if your data is not anymore online, maybe someone has it, and maybe someone can access it. So, like I try to tell my father multiple times, be careful what you post on the internet. Whatever is online can be collected. We will see how to do the legal stuff, but there is a lot of illegal stuff that you can do. So, another thing is we use data collection methods, but when the data we want to collect is online, we use web scraping, we use APIs, blah, blah, blah. Oh, yeah, sure.
My question was about example. If I post something like it comes to personal experience, anti-government, and then I take down the post later on, does that post get stored, and do the governments have access to it? Could the government access those kind of posts later on if they want?
Very good question. So I think it really depends. There are two answers to this. So what you're asking me for the crowd is, if I post something that maybe my government doesn't like, and then I take it down by myself, is that data still somewhere? Well, if someone screenshotted it, it's on someone's computer. If the company, let's say Twitter, stores the data for, 6 months after you deleted it, then it's on their computer. We don't know, but someone has it. And if governments pressure these companies, they can or they must give this data to them. There have been cases where, at least in Italy, there was a very crazy trafficking of child pornography on Telegram. There was a Telegram group where people were exchanging pictures. And of course, when the first news started to pop up, people deleted their posts from their texts and their images from from Telegram. But first, the police had already archived them because they were in the group. Second, Telegram was forced by the Italian government to provide all the data they had on that group. And that included the posts that were deleted by the people. And indeed, if you use WhatsApp, somewhere when you delete a post, a message, you can delete a message for everyone. Like, I delete a message and nobody else sees it. But somewhere it is written, I don't really remember where, it says WhatsApp might still have that post for a while, then we will delete it. So at least the EU requires that the data that you have, that a company has, they have to, if it's about someone that is, for instance, an EU citizen, they have to keep it there only for the time that that data has to be used. So if a user requests that their data is removed, these companies must do that. They can keep it for slightly longer. There are some technical stuff, but then they eventually have to remove it. Anyway, just a second. Anyway, if Mr. Elon Musk decides that, yes, that data must be stored, but first let me save it on my personal USB. Just in case. They can do that. They can just not tell the authorities, and they probably will do that. Like, I expect that since text now is so important, I expect that these companies, they might just not tell, move the data somewhere else, somewhere secret, and then train LLMs on that. Anything can happen. You don't really know what happens inside there. There is no way of telling us. I'm not saying these companies are evil, but let's say if they were evil, they could do a lot of bad stuff. That's it. Your question?
Yeah, so the message that we read frequently on our WhatsApp programming, right? Messages here are from end to end encrypted, it writes.
Yes.
So it means that we shouldn't trust it so much, this message.
So if
I got from what you said.
if it's end-to-end encrypted,
Yeah.
then it is secure. It only exists on the devices that receive that thing. So all the things where you log in and all the things where the other person logs in. So this is trustable. So of course the only entity that guarantees that that's trustable is WhatsApp. It's Meta. So if you don't really trust Meta, I don't know what to tell you. Yes. So, I mean, if someone were able to expose them, to discover that those data was supposed to be deleted and it wasn't deleted, well, it would be a very big trouble for that company. So, I expect that if they are very bad, they are so good at hiding it. And if they're not bad, then just let's trust them. And
But legally, we can sue them, right? If we find out.
I'm not really a legal expert, I don't really know, but I guess you could. Any other questions?
I have one example for you. on that.
Sure, let's go.
It would be helpful for you to understand that. There's a Turkish version of 4chain, which is probably you all aware of. One of the teachers from Marmara University has banned some kind of command over there. Right now, when you go into that webpage, it says like this. I cannot translate that low statement, but it says it's banned. But Wayback Machine revealed that when you go back. So like sometimes it does.
So let me just repeat it for the crowd. There is a website that's like 4chan, right?
Yeah,
4chan. Turkey. So 4chan is a very nasty website. It's like a lot of people anonymously commenting on whatever's happening in the world, exchanging sometimes illegal stuff. It can be pretty nasty. I would advise not going there. And there is a Turkish version of that. And apparently a university professor?
Yeah.
What did they do?
He legally banned the commands, so it's deleted.
Okay. So basically now it's
Yeah.
so now it's not accessible anymore. But if you go back with the Wayback Machine, that tool I told you, you can access that still. And there is probably no way of taking that down because the Wayback Machine is not owned by anyone. It's just, it is on someone's computer probably, but it's not. There is no legal entity you can go and say, okay, take that down. Also because if you claim that something you do is for research or for archival purposes or something like that, you are free to do most of the things you want to do in the name of research. We'll talk about that just right now. So,
There was a question here.
oh, sorry about that. Again, poor eyesight. Go on.
So my question was about using the Wayback Machine for access to social media content that is no longer now accessible for us as researchers. Let's say I'm working on a specific region and I want to analyze political dynamics and the interaction and the impact of a specific platform like Facebook.
Sure.
It's not accessible now for me because of what happened to Meta. But can I access data from before that?
So what the Wayback Machine does in the case of social media is it collects the main page before logging in. So you cannot access the posts. The only way you could access that data is if they are still available through the API, or probably more harder to use web scraping, go back, find the posts, and so on and so forth. But so working with social media is nasty nowadays. Probably I would first look for a data set online. Just Google Twitter dataset on blah, blah, blah. Maybe someone has published it. Maybe there is a research paper associated with it, hopefully. But yeah, as we will see, accessing social media data, it will get harder with time. So let's just collect everything now, right? So, no other question? Okay. So the fact that something is public does not mean you're doing a good thing to collect it, right? As I was saying to some of you, I am not a computer scientist. At least I am partly a computer scientist, partly a social scientist, and I've been exposed to a lot of discourse on ethics, legal stuff, what I do, what I cannot do. But as you probably know better than me, these things are blurry. So what's ethical for me, it's not ethical for you. It's culture dependent. It's very tied to the individuals. So here I just wrote down 4 things that I believe are kind of universally true. So context matters. Just take whatever that means. Context matters. And most of the times when you talk about something that's ethical or unethical, it's the context that makes it ethical or unethical. Would you kill Hitler if you go back in time? Some of you would. Some of you wouldn't, because killing is bad. Social media users, online users, did not write for research purposes. They probably didn't think, when I post something, I don't think, the researcher from Ibn Haldun University will collect my data. So, what should we do? Again, it's up to you. Vulnerable population require care. So when you work with vulnerable populations, I don't know, I would personally have special care, like the findings that, but probably you know this better than me, the findings that you take from this data, the way you collect this data, I mean, it has to consider that there is some vulnerable population involved, and that you can do very nasty stuff with public data as well. Yeah, I know if this is too vague for you, we will just be more practical in a second. So when you register to a website, again, Italian, have to move. When you register to a website, you click on accept to a very large page of condition, terms and condition, terms of service. You click this, and I don't think only legal people like to read that stuff. And that's for a variety of reasons. The first is the way it is presented to you. The first time anyone, even I like to read very much, but if you present me like a very long text, written very small, right? And it's full of legalese, a lot of things that I don't really understand, I will never read that. I just click accept. And if I don't click accept, I cannot register into the website anyways, right? That's nasty. But that's what the terms of service do. They regulate what you can and cannot do on the platform. So some terms of service, when you log into Facebook, you say, Facebook says, you have to agree that you will not scrape my website, ever. You can do it, but you will be violating Facebook terms of service. Another thing, for instance, Twitter, when it allowed access to free APIs, you could collect the data, but you could not publish it. Problem, reproducibility of research. I can say whatever I want. You cannot check it. You have to collect the same data. How do you do it? How do you know? What if someone deleted their post in the meantime? You cannot access it anymore. But this is a good way to regulate data usage. That it's trying not to organize what you can and cannot do. Exactly. That's what I was talking about the LinkedIn terms of service, that they prohibit the use of bots to scrape user data. Violating these terms can lead to legal actions by LinkedIn. And LinkedIn sued this HIQ company because they were trying to do that kind of stuff. And that's also why now they also change their HTML every now and then. So if you are registered to this kind of thing, to this kind of platforms, you probably signed one of these contracts. But using an API, so accessing data in a structured format, implies that you have agreed to this. That's why you need to register most of the time, request for permission, and what they ask you is you have to agree to this. So it's not given, it's not automatic that they will pursue legal action, but they can if they want. So I would say unless you cause too much of a trouble, nobody will do anything. You probably will not be noticed, but it can be noticed, and you can be sued. We were expecting this, right? So the data you collect, or rather, let's start from this. Who is the owner of my Facebook post? Go on, try it. Good question, good answer. So someone says you, someone says Facebook. Who says Facebook? Raise your hands. Don't be shy. Who says you? Okay, who says something else?
Both of us.
Both of us, okay. So I don't know the answer to that question, but everyone will give you a different answer. In the EU, data is property of the person who produces it. But my Facebook post is not on my computer. It's on Meta's computer. So if it's physically on Meta's computer, the US rules apply as well. And they can be, disagreeing with each other. And who has precedence? I don't really know. I'm not a legal person. But this is some nasty stuff that we have to think about. At least I wanted to simulate a very brief discussion on this. There is copyright laws involved. If I collect data from a web page, let's say I collect Twitter posts. Let's pretend it's still possible. And someone shares an image of, a copyrighted document, or a copyrighted image, maybe some art piece that's still under copyright. Well, now you violated the copyright laws, because now you have that piece of data, you have it on your machine, on your computer. That's violating intellectual property, like violating copyright. So this is, again, there is no way around this. If you collect data, or a lot of data from the web, you're probably going to violate a bunch of things. So this is not legal advice, but just expect that, limit this if you want, if you can, but just expect that some rules will be broken with data collection. That's just how it is. Now, if you're a very legal, very ethical person, most of the time, every time I interact with people that have very strong opinions on these kind of stuff, what they will tell me is, okay, I will not collect this data anyway. And I understand that, I agree. Then someone could say, okay, but it's for research purposes. What's more important? Is it more important? I mean, if you want to make money out of it, well, I agree that that's nasty. I wouldn't do that. But maybe like nowadays it's hard to get this data from internet. And now I'm having a hard time doing my analysis. So what I do in my research is two things. I develop algorithms, and then I apply them to real data to solve some problem. Okay, maybe limit the diffusion of fake news, or study if discussion on a topic is polarized. So estimate the opinion of users, try to understand if there are opinion shifts that are related to real-world events. That's mostly of what I do, broadly. This requires a lot of data, a lot of user data. What's more important? Like, well, for me personally, that's advancing science. But of course, that's what I do, so, you know. But I mean, when you use data, when you collect data, you have to kind of expect that some rules will be broken. Unless you decide to, I mean, just not, you know, collect data programmatically. That takes a lot of time. But even in that case, I mean, it's a gray area. That is my main point. Sorry if this is a bit too vague and I'm repeating myself, but the point is here, everything is a gray area. There are very few staples. Rules change from state to state. Briefly, we will see how the EU handles the thing, but as you know, the EU is very good at making laws, less good at enforcing them. So, you know, problem even there. And exactly, GDPR. I don't, so the GDPR is basically this regulation that protects user data, specifically of people in the EU. But if you work on social media, and you want to collect 100,000 posts, you have no way of knowing that the people that you're collecting data from are EU citizens or not. I mean, you could filter geographically, but it's not always possible. So you have to assume that these rules apply to you as well. The stricter the rules always apply. Let's reason with that. So we take the stricter rules, the more restrictive, and we go by them. Because that way we are sure we're doing everything correct. So a lot of problems here. What does GDPR do? The main point is that they want GDPR protects user data. User data must be stored according to specific rules, not for too much time. It has to have a specific purpose. If that purpose is no longer accepted or viable, or whatever, that data must be removed. If you're a EU citizen, you can, but I think this applies to most people also outside the EU, because the companies then conformed and applied the stricter rules to most of the users. If you are a EU citizen, you can request Meta to delete all the data that they have on you. That means deleting all your posts or your comments, everything you said in private. Everything that you posted on a Meta platform can be removed. Of course, again, if they save it on a USB stick, you don't have no way of knowing. But that's what GDPR is supposed to protect. Data collection should be limited to what is necessary. So I can, if I need data on, I don't know, I want to learn what people are saying about something, then I don't care about the links, the likes, who liked that post. So I cannot, if I collected more than I need, I would be violating GDPR. And yeah, of course, the other very interesting one is integrity and confidentiality, where data, if you collect this data, you have to be very careful who you share this with, because they have to comply with GDPR as well. You have to disclose that you share this data, how you shared it, for how long, for what purposes. So this extends to them as well. Again, this might not apply to you, but it's safe to assume it does, just in case. So again, this is a copy-paste from another course, so I know that we are not. But the idea is that the EU recently, how to say, issued this Digital Services Act, where this is trying to regulate how the companies, they call it VLOPs, very large online platforms, should treat your data and should offer you some kind of service. And one of the things that this thing says is that this platform must provide access to researchers. And again, the law is very, very permissive, very cool, and then nobody complies and nobody does anything. But it's safe to expect that maybe in time, Twitter will provide a free API just to conform to this for researchers. And if you're not a EU citizen, you can collaborate with EU citizens to do that. So that's also another way of getting around this kind of limitations. For some time, Facebook allowed to collect data if you were a US citizen, if you could prove you worked for a US institution at least. I think it was something like that. I have no ties with the US, but if I wanted to collect data, I could just ask my colleague from Cornell University, collect this data for me. Let's work together. Okay, so this is something else some people can do to get around this kind of thing. Again, ethics. But what's also important is data protection. Again, you need to store it in a secure way. That is, if it's on a machine, it can be hacked, but it has to be. You have to put a series of protections in such a way that this is safe. We will probably see how to do that. No, that's. And another thing. So for me, sharing data is very important. So as I would say I have two souls, one of a social scientist and one of a computer scientist. My computer scientist soul says, my code should be public. All the code I've ever written is published online. I want to do that with the data as well. So when it's legal, all the data that I have analyzed is public. But I work with social media posts. So what do? So the GDPR, I don't think they invented it, but the GDPR found this kind of compromise where you can do pseudonymization. What does it mean? Basically, you take the data, you reduce it in such a way that you can still do your analysis, your work, but you remove all personally identifiable information, which means phone numbers, emails, names, locations, and a lot of other things. There are automated pipelines in Python, in other languages, also paid services that will check that for you. So this pseudo-anonymization, it means the data is not really anonymous because maybe somewhere there is still a key to go back and get back that information, Because maybe you need it for research purpose. Maybe you need to contact the person who has given you some kind of response to a survey. Well, you want them to be anonymous, but you still need a way to maybe check on them if something is off, or if you want to proceed further with the interview, something like that. So this is also something that's very on point. So again, what is very important for me is reproducibility of research, and so again, all the data and the code that I work with is public. This is a data set that we collected 2 years ago, 2024. Blue Sky, if you don't know it, it's basically a Twitter clone, which means it works like Twitter. Sorry, I should say X, but I don't really, like X. So what it does, this platform, it's basically a copy of Twitter. It works in somewhat the same way, but it's owned by a different company. This company's motto is a world without Caesars, a world without big, powerful men. Okay? Well, bad news, they're becoming a tech giant as well. So in a time where API access was reduced, so no Twitter, Reddit was very hard to get, this platform was created, and they said, free data for everyone. So Blue Sky, in 2 clicks, 2 lines of code, you can collect every public data about any user that is on there. I could go there, type my username, and say all the data from this person, everything I posted, everything I liked, everything I follow, everything, blah, blah, blah, whatever. If I did something to Blue Sky, everyone can do it. Of course, if you don't want this to you, don't register to Blue Sky. So we saw this as an opportunity to provide an open data set, of course, pseudo-anonymized, as we've seen, and GDPR compliant, for social science research. What we did was basically collect most of the data on the platform. This is, it was, at the time, it was 5 million users. Now it's 50 million users. I mean, the platform is 50 million users, but we only have data about 5 million. And we collected all their posts. We checked, removed emails, blah, blah, blah, all personally identified information. And we studied their network, their friendship networks, what happens on this platform, if it is any different than other social platforms like Twitter. Is there less toxicity? Is there less, or is it polarized? For instance, what we see is that people in there are mostly left-leaning. So you could call it a left-leaning echo chamber if you want. So this idea that there is mostly one opinion that circulates and all other opinions are discredited. This is very frequent in all social media, but this is true as well. So I wanted to do a good thing, but I see a lot of frowns in the room. So I understand that that's blur, like there is a thin line between what I expect to do, what I wanted to do, and then what some people may find unacceptable. Because if you're a Blue Sky, if you were a Blue Sky user before March 2024, your data is in there. So let me say this first. If your data is in a data set, there is most of the time a way to request that it is removed. So this is also why I have at my university on a computer, I have a file with the usernames of these people. Because if someone texts me and says, or sends me an email and says, okay, I saw that maybe I am in this data set, or I think, or could you check, and I want to be removed. I have to, if I anonymize, the public version is anonymized. You cannot look at the usernames here, but I have to know. Because if you want to be removed from the data set, I legally must provide you a way of being removed. So this here, you see there are multiple versions of it. This is because some people requested to be removed. So, and every version is like 100,000 people. So what happened, before looking at the post, please look at me. What happened is someone, one day, published 1 million posts from Blue Sky, which is very easy to collect data from, on a very popular data science platform for machine learning. So 1 million posts is nothing for AI training. And 1 million unfiltered posts is even less. So it's garbage. You can't do much with that. But the guy published this. So he didn't anonymize anything. He left everything like in the clear, which is very bad. Don't do that. But people went, for very good reason, went crazy. So people said, but this, we moved to Blue Sky because we don't like Twitter that uses our data to train LLMs, Grok. And then we moved to Blue Sky and everyone collects our data. Well, Blue Sky allows you to do that very easily. So people were very pissed. So one day, someone else, a librarian, published 2 million posts. He got fired. Nobody noticed that there has been 235 million posts, our dataset, online for months. So if we don't have many citations, maybe we cannot do very good advertisement. But the thing is, people noticed that we published a lot of data, and people didn't like that. Really didn't like that. Really didn't like that. So, luckily, I was not in Pisa. My home address is public. Luckily, I was not in Pisa when this happened. I don't know what was going on, but the thing is, you gotta be careful, okay? So it's very here it's a very delicate thing. You want to do research, you want to do a good thing, but people will not like it. And some of you probably will say, I would never do this. I would never collect that much data. Why do you need it? Well, for the things I have to work with, this implies to be to have that much data. And you could say, okay, do something else. I want to do this. And my final point here would like to be that methods shape knowledge. Methods shape knowledge. So data collection is not a detail, is part of the research process. What you can collect, what you end up collecting, the subset of the data that you are actually analyzing shapes your result. And who knows about p-hacking? Raise your hands. Okay. So p-hacking is a way of that researchers, like quantitative researchers, cheat. So there is this thing in statistics, it's called hypothesis testing. So I use some fancy mathematics to prove or to estimate how likely that I am correct if I do an hypothesis. So I hypothesize that people on Twitter are more toxic than on Blue Sky. I test it with the statistics, very fancy tools. And then I get a number. And this number, if it's higher than a threshold, then I'm wrong, or I'm not right. And if it's lower, then I'm right. So I want it to be lower, because I want it to be right. I want my result to be cool and be published and whatever. So what people do is they cut the data in a way, that's p-hacking. They cut their data in a way that when they run the simulation, they run the statistics stuff, then it turns out that they are right. So this is when people do it deliberately. Okay, that's a bad thing. But this implicitly happens based on the data. Yeah, sure.
But I guess in social science, actually, in the case you just mentioned the example, even if he is wrong in the hypothesis, it's also something new finding for us, for social sciences.
Sure.
It could be true for the positive sciences.
Sure.
But I think for social sciences, that it says those kind of people are more toxic. It's also a very kind of we can use it.
I agree with you 100%. I think the problem here is maybe in the most quantitative science, there has been a time frame where journals would only accept results that had a very low p-value, which means very strong hypothesis that turned out to be correct. So for me, if I don't get, if my hypothesis cannot be proven, that's still a result. But I mean, on paper, it's a weaker result. For me, it's very important. But maybe the reviewer will not like it. So since now academia, as you probably know, is becoming very toxic, and maybe it has always been, I don't know, been here for less than you probably. But the thing is, now people want to cut the data in a way that it is appropriate or considered appropriate or considered a good result, an outstanding result. But this happens even if you don't want it. Because the sample, that's a sampling problem, right? The data that you get, well, it doesn't really depend on you. If you do a study on Twitter, you analyze a Twitter population and not all of it. Not all the population in the world, not all the population on Twitter, not all the population that talks about that, only that, the post that you could get. You have no way of knowing that Twitter gave you all the data. You have no way of knowing that nobody deleted their posts. And even if in any quantitative stuff, if you tweak the numbers slightly, the numbers change by a lot. So again, what we see is a very narrow subset of the social reality. I mean, I guess you could figure that out, but with data, like for me, it's very obvious. I collect 200 million posts, and then when I have to do my research, I have to cut them. The ones I can actually use are such a small subset that sometimes I wonder, okay, but is my research valuable anymore? Who does this apply to? So the findings that I draw from my research never applies to my father, who never uses Twitter. Okay, so again, data collection process is a key step of this research process, and yeah, I think this part is done. If you have any questions,
I have a question.
Sure.
Basically, when our hypothesis is not proven, it becomes a null hypothesis.
Yes.
But the results are still being published. But my actual question is, you say that you can also somehow tweak the p-value.
Yes.
If I'm reading a paper and I'm reading a hypothesis and I see that the results are very strong, is there a way to ascertain that the p-value has been tweaked or manipulated? So I know that some institutions have very strict controls. So what your colleague is asking is, how do I find out if some paper that I saw has been p-hacked? So if the researcher was nasty enough to tweak with the data. The short answer is probably not. What?
You can manipulate the data.
Yes.
You publish it, so you can.
Exactly. So if I publish my data, just a second, and then I'll come to you. If you publish your data, let's say you want to prove that people on Twitter are more toxic than Blue Sky, who's stopping me than publishing only toxic posts on Twitter and then removing the good ones? You will never know. And when you find out, I can just say, but that's what the API gave me. I don't know. So again, with data collection, I think this applies to all sciences. I think biology also works the same. I mean, I have this finding on this very particular, I don't know, blood cell. I don't know if this applies to everything. But with data collection, you have to deal with it somehow. You have to confront reality and say, okay, the data I have is not the complete picture. Maybe to some extent, we try to make it representative, but it's not always clear, and sometimes you can fake it. So you had a question.
Yeah, I was wondering about the trust on the data. For example, you mentioned that, for example, you can collect it from any website. Let's say that, for example, government want to put some narratives, and now they are having people as well as softwares which are, for example, let's say that tweeting positively about some policies or something.
Mm-hmm.
Is there any way to you trust on that data? It's not manipulated. It's not being compromised by companies and government that they want to build up the narrative. For example, recently there was a news: Israel is putting billions of dollars in ChatGPT.
Yes. So. So that is, I think, one of the best questions when it comes to these kind of topics. How do I verify that information online or anywhere else is true? And this is, I would say, an epistemological question. What is truth? Okay? So for me, the fact that something is true has to be certified by someone I trust. So when I was younger, I would eat all of the cake my mother made, and I would force my brother to never tell her. So when my mother asked who ate the cake, I would punch my brother, so he would say, I ate it. My mother trusted me and trusted him, but she was wrong in trusting me. So this applies to everything. If there is data on your website, on your government website, if you trust your government, then the data is probably good. If you don't trust it, I don't know what to tell you. There are some independent organizations that fact-check data, that fact-check information. In Italy, the way they do it is some newspapers have this kind of fancy title where they can prove or they can disqualify some news. But that's very problematic, right? Because if I manage to control that, then I control the truth. I control the post-truth, right? So the short answer is no. There is no way of knowing. The only way of knowing is if someone you trust then says that's correct. Again, very problematic. I agree. And on social media now they're doing, I'm not really using Twitter at the moment, but they're telling me that there is this thing called community notes, which means that the community kind of comes together and decides on truth. But you're a political scientist, most of you tell me that that's very easily manipulable. And I tell you, as a half computer scientist, that I can put 100 bots that tell the wrong thing, and then in the grand scheme of things, the wrong thing will become the truth. So that's called information manipulation, something deception. I don't know. There is a field in computational social science that tries to study the effect of bots. For instance, we were trying to study discussions online about what's happening in Gaza, and what we found out is that. So this only applies to what we found out. I'm not making any general claims. What we found out is that our AI system detected that most of the posts with pro-Israeli propaganda were bots. So an hypothesis could be that someone is using these bots to inflate the numbers, to diffuse some kind of information. Maybe our AI system is wrong. I don't really know. We tested it, I guess. But again, information, what is truth? Everything is manipulable if you're good enough in doing that. And if you're a government, or if you're a very strong tech giant, think of Facebook with Cambridge Analytica, you can do almost anything and no one will find out. Any other questions? Again, if I don't see you, please wave. Okay, so we have a lot of time, and everything I had to tell you, like the theory part, is over. But I know that you've been stressed a lot about learning Python, and I mean, if you feel stupid when you look at the code, that's totally normal. If you don't, you're doing great. Maybe you picked the wrong field. But learning Python is very hard. I mean, can be hard at the very beginning. You feel stupid a lot of the time. So in the code that I will show you this afternoon, basically, we will use some libraries that interact with the APIs of many services. And the things you have to change really depend on your research question, but they're very small. Most of the logic of the code is already there for you. And again, computer scientists like plagiarism. So you can copy the code, use it for 100 years until it keeps working. But as I was saying, I work with social networks. So in the time that we have until lunch, I wanted to tell you about network science. So this summer school, the winter school, is mostly about text, working with text. But many social processes cannot be explained by text alone. So there is, I would say, a complementary science that not only studies text, but also society. I mean, you tell me that's sociology, I know. But you think of this as a kind of a computational sociology. I have some post-credit scene. If you like Marvel movies, I like them too, and I wanted to emulate. Very briefly, I don't want to bore you with theory, and I guess I will keep this very short. But the web is a network, okay? Collecting data from the web means moving through a network. And especially when it comes to social media, well, social media is our network. Social media are networks, right? Social networks, you know. Think about you surrounded by your Facebook friends. So each friend has its own friend. That's a web, a network again. So network science is the science that blends together social science, physics, mathematics, and computer science, and tries to study complex systems like the social system, with very simple mathematics. I don't want to bore you. Real-world networks, scientific collaborations. You have researchers that co-author papers. Maybe that's something that might interest you. Airlines communications, co-acting networks. So these kind of network things networks are kind of everywhere. If you think about any system, you can probably find a way to represent it as a network. And social networks especially, like it's such a natural way that when we will work with collecting data from the API, you would say, that's a lot of interactions between these people, but why store it as a list of interactions? Why not store it as a graph, as a network I could look at? Again, other things you might be interested in, mobility, in the individuals that move through a city. That could be a network as well. A friend of mine likes soccer very much. He studies soccer networks. What this means is the players in the field are nodes, and they're connected if they pass the ball from one thing to the other, from one player to the other, and he found out that the structure of this network can predict the winner of the match. Network science is everywhere. If you've never heard of it, well, they don't do very good advertising. But again, it brings together a lot of fields, mostly graph theory. Graph theory is a subfield of mathematics that's very boring. So I don't want to bore you with this, but you know, that's a graph, that's a network. And some can be directed, which means you have a direction, and some can be undirected. If I don't care who talks to whom, I just care that they talk, I connect them with a simple network. I call this a degree. The degree is the number of connections I have. So on social media, an influencer has a very high degree. So if I look at the structure, I can only tell by looking at it that someone is an influencer. That could be of interest to you as well. Again, I will leave you these slides in case you want to, this is useful for your research. But again, think about COVID and how the virus spreads over contacts. That's something that travels through a social network. So there is a subset of subfield of network science that study epidemiological diffusion. And of course, you care about paths, the paths that these pathogens take. Distances, again. You can understand by looking at the network whether someone or some actor, some person in the network is important or not. And you could say, okay, if someone has a high degree, so has a lot of connection, then he is probably important. But that's not really always true. I could say that someone who is important is someone who is connected to other important people. So, I don't know, if I knew Donald Trump, even if I'm not very popular, maybe I am important in a way because I know Donald Trump. Again, if this sounds like a bunch of random things to you, if I'm going too fast, please stop me. This is just, in the short time I had left, a way of exposing you to another branch of computational social science that you might find useful, especially when you collect data, because social data from social media can be represented very easily with networks. No issues with that?
No, it's all good.
Great. So, again, these slides are full of details because I thought, since there is not much time to treat about this, if you want to explore it and use it in your own project, that would be great, but you can explore this and also ask all of us. All of us are familiar with network science. So here, just randomly, a couple of ideas of what it means to have different ideas of importance in a network. You don't need to learn any of those, but the idea is, if I look at the number of connections I have, I answer the questions, how many friends do I have? Then there are other measures that tell me, are you connected to important people? How many important interactions do you have? What is your average distance within the rest of the network? So you see, you can define importance in a network in very different ways. There is, the last one is how much do you help the network to stay connected? This is very critical in diffusion of information on social media. People who have a high betweenness centrality, they have, and you will see eventually how to compute it if you're interested, they are the ones that if they spread bad news, like fake news, everyone gets it. Yeah, do you like Game of Thrones? Have you ever watched this series? So there is someone online that they drew a network of people acting in Game of Thrones. So you see that this is, again, you can make a network out of everything. And you have, I'm not really familiar with Game of Thrones, but this is a very popular series, so many people know it. But apparently those people that you see with the very big font are very important characters, and this emerges simply by looking at the network. And some communities, some parts of the network are very, close together. You can see that there are some nodes that are closer to each other than to the rest of the network. That's called communities. And communities are very important if you think about echo chambers on social media. Think about a group of people discussing the same thing and always have the same opinion. That's critical for information flow because you are influenced only by the things you see, not the things you don't see. The information don't arrive to you. So if you are in this place of the network, so this is not a social media network, but if I'm here, I have no idea of knowing what's happening here. And yeah, this is something about centrality. How do you find a job? Good question, right? So there is a researcher in the 50s or 70s. I think his name was Milgram. Anyone know about Milgram? So he did an experiment where he found out, no, sorry, not Milgram, Granovetter. He found out that people find jobs not through their friends, but through people they barely know. Any idea of why is that?
Can you repeat the sentence?
So people find jobs. People are more likely to find a job through someone they barely know, so they don't know, not a close friend. So my job as a researcher, the contract was shared with me not by my best friend, but by someone who I talked about at a conference once. Do you have any idea why is that? They know you on a professional level. That could be a very good explanation. Because if, networks, social networks have different layers. I am connected to Franco and Francesco and Giordano on a professional level. And so we explore the professional world together, but my family, even though it's part of my network, it's on another layer. They don't have anything in common. But another answer to that question could be that the information that you consume, the information that you get, is the same information that everyone around you gets. Here, you're all learning about computational social science. If you go to a biology class, nobody knows about computational social science. But you can tell them. That's exactly the same principle. That's what is called the strength of weak ties. The weak ties, the connections that are not that important, that connect us to other parts of the network, are those that are more important in some other sense, through which the information changes. Think about, again, COVID. A random person moved from one country to the other, spread the infection all over. That's how it happens, And that's what you can study with networks as well. Do you know about Dunbar's number? No social science, no sociologists here, or anthropologists. Dunbar's number is basically the theoretical maximum number of connections you can have. You can have up to 150 friends. After that, your brain does not remember them. If you don't remember that the name of a very cute girl in your kindergarten class, that's because of the Dunbar's number. And your connections are wired in that way, in circles, concentric circles, one inside the other. Which means I have very few, very close friends. Then I have a slightly larger number of more distant friends. And then the people I know are a lot. People I could name, but maybe I never talked to them.
That's very good. I have more cousins than this number.
Really? So this could be interesting because it could be culture dependent.
This is one of the best interventions someone has ever made.
Now you feel you have
So again, tie strength, the fact that some ties, some links are more important than others. I think at the top of your mind, you can think about the people that are very close to you and the people that you haven't seen in a very long time, maybe some of your cousins. Facebook friends are organized in the same way, as these researchers found out. Where you have all your friends, is a very dense network, there is a lot of connections. If you look at the relationship that you maintain across time, after a while, the network reduces. If you look at the people you have communicated at least once, that's another network. If you have exchanged communication, you see that there are very few links now. So the people you talk to on social media are a very small subset of all the people you are connected to. Very briefly, let's conclude before lunch. Is this too much? Are you interested? Are you bored? Yes to bored or yes to... Yes, we will see that after lunch. But since it's very, how to say, copy and paste, it will be very quick.
Some kind of parts of like knowing how to do social science already. That's most of the information you need. Like maybe the technical skills would be more.
Yes, we will see the technical skills after lunch. Very quickly, networks are organized in communities. And as we have seen, communities are important because of how information moves through the network. Again, social networks, but think about international networks. I once read a paper that talked about the peace treaties or, links some way between different countries. And the thing that the researcher found out is that most of the countries are connected to each other and have a relationship to each other. And the one that is kind of isolated is France. I wonder why that is. But yeah, communities are these kind of blocks that you find. And of course, the information that travels here has a hard time reaching there, right? And then there's another thing. Sociologists will tell you about homophily, also social psychologists. Homophily is this principle that we seek people that are close to us, that are similar to us. So I am a white male in my late 20s. Most of my friends are white males in my late 20s. Most of my friends speak Italian or Sicilian, or both. Most of my connections in the past week have been with researchers and students. Most of your Facebook friends have the same characteristics that you have. And again, this impacts how information travels. So yeah, for instance, race. This is interesting as well. Homophily, this principle here that similarity breeds connection, is a link creation mechanism, a mechanism that creates a link, but can also be an influence, a consequence of social influence. So if you want to have dinner tonight, and maybe you want a pizza, first of all, how do you get pizza in Istanbul? But anyway, if you want pizza, and you're with your friends, and your friends say, but I really want, I don't know, a kebab. And the other friend says, okay, I want a kebab too. It will be hard for you to say, no, I want a pizza, unless you're very, energetic and you have no problem. I will feel very shy, and I wouldn't say that. So I would say, like, okay, let's go for a kebab. So this is kind of applies to everything else as well. The peer pressure, the pressure of the peers put on you unwillingly most of the time. And this is something else that can be studied with this kind of models, networks. What can we do with networks? Migration studies. Someone into migration studies? Great. So what you can do, for instance, is study what we did back in 2021, was to study how academics moved through countries. Okay, so academic migration because of grants, because of political issues, citizenship issues, visas, blah, blah, blah. Or the Turkey crisis, which most of you are, I guess, familiar with. I didn't remember this being in the slides. But yeah, we studied how people moved, and this can be studied through networks because there are some digital traces. If you use Google Maps will tell you when a place you want to go is crowded, because Google has access to all of your phones and can tell if you're in that place, if there are a lot of people in that place. And researchers can access that data as well. So you can study how people move. Well, you can really track the single user because that's illegal in most countries. But you can do it for a very large number of people. That's what I like to do. Polluted information environments. I mean, I don't like to pollute them, I like to study them. So I spend a lot of time on social media, too much time, my mother would say. So I like to study how people discuss about sensitive I have very strong political opinions. So, but I don't like to post much on social media. I like to read because I like to feel better with myself. I look at these stupid people saying these things. So network science combined with the tools you will see tomorrow can tell you, for instance, something I would do in a research paper is estimate the opinion of a population of people on social media. Let's say, depending on the things you post or the links you share, I can estimate, well, if I share links that talk about Donald Trump in a positive way, you can guess my political opinion. If I share links that talk about Donald Trump in a negative way, you can guess, well, you're not actually sure, but in the large numbers, statistically, you can be certain. I know this is sensitive to most social scientists, but there are statistical rules such that if numbers are large enough and you take care of the steps you take, you can be sure most of the time, and that's enough to draw conclusions. So we study how can we model how fake news spread, how can we stop them. Science of success. This is what my friend was doing. This is a football match, Real Madrid versus Bayern München. And what they're doing is these are players, and they're connected if they exchange the ball somehow. And the structure of these networks can predict even a partial structure. So you know that soccer matches are divided into two, we call it times in Italian, I don't know. Halves, exactly. Into two halves. If you analyze the network in the first half, you can get an insight on who would probably win in the second half.
Unless the match is rigged.
Yeah, probably. Good point. And the people that are doing this are being paid a lot of money, not as researchers, the people who are hired by Juve and other big football teams. You can, with network science, you can understand which firms will succeed. There are a lot of people doing financial speculation with network science. And then urban planning. Do you know about the 15-minute city paradigm? This idea that in any city, all the basic facilities should be within 15 minutes of walking. Crazy in Istanbul, right? But yeah, this can be, when you plan a new city, it can be done through network science. Yes. So I'm really done, and we can go 10 minutes earlier. So again, I guess that this is not what you were expecting from today, but I swear this is very, very, very related with data connection. data collection. If you collect data and your data looks like a graph and you don't collect all of it, your graph will have holes in it. And these holes will mean that you will think that, oh, data cannot, like information cannot move from one place to the other. And then indeed it can, but you just don't have the data. So if you have any questions, we can talk about during lunch. After lunch, we will see how to collect data from the web and then with APIs. Welcome. So very quickly, before we move on to the techie part. First of all, everything is clear. You have any big question that you forgot to ask or some doubts that are not related to the technical part, to the practical side? Wow, I'm such a good teacher. Wow, great. So a question I was asked a lot during the break is about social media and how the algorithms, if I collect data from social media, does the algorithm do anything? Will it bias my result? We don't know for sure, but what in theory, when you collect data from social media with an API, I underline this, with an API, you get the data unfiltered. So there is no algorithm in the sense that the algorithms that personalizes what you see, it should not be there. If you do web scraping, of course you log in to the website and the website shows you what it thinks you like in social media. That's how it works. So in that case, there is an algorithmic bias. Let me think about if there was any interesting question. Something still related to social media. The algorithms that serve you content, that tell you what you see, basically what they do is they learn what you like by how long you scroll the platform, how many milliseconds you spend on each video, but also they personalize you based on what your friends like, because of homophily that we saw before. So if my friends are very passionate about sports, the algorithm can assume that I'm passionate about sports as well. Okay? All my friends, we go to the cinema together, we watch the same movies, we have similar tastes. So even if I don't post about movies, that's something that the algorithm knows. And have you ever had the sense that the phones, the smartphones are listening to us? Yeah, all the time, right? You talk about dog food and 5 seconds later you open Instagram, dog food advertisement. So, of course, there is no way of being 100% sure they're not listening. Let's trust them. But the real thing is, these algorithms are so good at predicting what will happen to you that because of also the social aspect of it. So how my friends liked, blah, blah, blah. That what you see does not only depend on you, depends also on your friends. So it's very, very likely that they will get what you like. So if I talk about dog food with someone that is physically close to me, which means that our location is the same, well, a platform probably knows that if you both gave access to the platform to your location. So a platform can do this. Okay, these two people are in the same place, have been in the same place for a long time, and one of them typed about buying some dog food. So the other one must have heard about it. So that's how it works. Questions about that? Great. So before, again, another brief thing, then I promise I will give you all the code that you need. So you will see this probably with Yanni the last day, but since you need to collect data, you need to do it quick, and you probably don't feel very confident with Python yet, you will 100% ask an LLM. I have nothing against that. But at least I want you to know how to ask in a good way. LLMs are not gods. They do not know in the sense that we commonly attribute to knowing. They produce things that are very, very likely. And the truth is very, very likely. So most of the time they are right. There are some ways to reduce the times that they are wrong. But it takes time. It takes to be very, very precise with what you ask. So in the slides, which you can find on Google Drive, after this last thank you slide, you see how to talk to an LLM. Okay? This works with 99.999999% of requests. Whatever you ask an LLM, the more you are precise, the better the result. Sometimes I say, I want a code that does this. Do it for me. But if I don't specify the output of the file, the structure of the file I'm working with, the specific library I want to use, or some specific constraints, well, LLMs are not yet inside of your head, so they don't really know. You have to tell them. So this is an example of how to produce text summarization, just as an example. Maybe you don't need that, but this is a very good way of structuring a prompt, so a request to an LLM. The first thing you could do, this is very, very powerful, incredibly powerful, is saying them, okay, act like a very competent person. There is research that shows that if you ask them to be very good at something, they will be more likely to be very good at something. That's weird, but that's how it works. So here I'm asking to summarize papers about large language models. So papers about AI, okay? This kind of AI here. So I'm asking, act as an expert in that subject. You are very good, you excel at breaking down complex papers and into digestible summaries. So of course, it takes time to write this kind of prompt, right? But the quality of the result is always, most of the time, it's worth it. Then I want to give it my instruction. Very important, the instruction has to be either at the top or at the bottom of the prompt, never in the middle. The longer the context, the longer the things you write, the longer the information in the middle goes lost. So it's good to give small prompts, and the information has to be at the top. The most sensible information has to be at the top or at the bottom. Context. More information. The more detailed you are, the better it is. Your summary should extract the most crucial points, and the important is that they can help researchers understand the most important information. I want a format in a specific way. Of course, you don't have to use all of these. Only the ones you need. The more you give them, the more it will be close to what you want. The audience. So part of the structure of the lecture of today was organized with one of the very popular LLMs that you probably also use. It is important to tailor the thing. So of course, if you need to write code, maybe you can say, write very simple code that does not require external libraries, for instance, so that it only uses the libraries that you have already. So here it says, the summary is designed for busy researchers that quickly need to grasp the newest trends, blah, blah, blah. The tone, maybe you need the tone as well. And at the end, I put the data, so the actual paper that I want to digest. Is everything clear? Any questions about this? So I am not sponsored, but in my experience, the best LLM for writing code, the one that is the most of the time gives me what I want, is not actually Gemini, which is a very powerful tool, but it's called Claude. Claude, it's C-L-A-D-U-D-E, but you probably know about that. They write very good code, in my opinion. They tend to be a bit wordy, but what you could do is, if you need to start from scratch, is you ask code, and it will probably explain what it does, but then you can say, explain it like I'm 5 years old. If you do this, you can, this request is so popular that it has its own acronym, ELI5, E-L-I-5. If you write ELI5 to the LLMs, it will explain it to you like you're 5 years old, very easy. So whenever you have problems, I would first look on Google, but nowadays people just first go to LLMs, so I guess I'm fine with that. Ask LLMs, or us, if you're here, and then try to work together with the code. To the best of your possibilities, please try to read the code and understand what it does. I understand that you're not very proficient yet in Python, but LLMs, even with this, LLMs can be wrong. And if they're wrong and you don't notice, well, that's a problem. Everything clear so far? So let's get our hands dirty. So again, this you can find it in the slides. Does everyone have access to the drive with the, right, yes. So ChatGPT, blah, blah, blah. Where was it? Ah, it's here. So if you go, should see the folder day 3. Okay. Day 3 has the slides and then the notebooks. Okay. So today we will see. So there are a lot of notebooks, but don't be scared. We will see all of them, all if there is enough time. But again, the code here is not, the code doesn't require much edits, much modifications. So you can use it as it is most of the time, just with minimal modifications that Gemini should be good enough to do. That's why I spent so much time on some things. Maybe you wanted the results quick so that you can work on your project. So the first thing we will see is how to collect data by web scraping. Again, I've had some questions. Some of you don't have this distinction clear. Maybe I was not very clear enough. Sorry about that. Web scraping means looking at the HTML with machine. HTML is that code with tags that we have seen this morning. So a Python program can read that and give you the part of that you are interested in. APIs are another way, a complementary way, that simplify you things. Only if the platform or the newspaper or whatever you're using that you're interested in provides you that kind of access. And that's subject to a series of limitations, prices sometimes, and whatever. So the first part, we will see web scraping. So web scraping is a bit hard, okay? It's a bit hard in the sense that, but don't be scared. It's a bit hard in the sense that since it's not, web pages are very different from one another, there are a lot of technical details, small things that you need to be aware of. Here we see the most general cases. For all other cases, either ask us or LLMs. I would prefer if you asked us, but I understand that time is a constraint. So in these notebooks, you see some exercises. I don't know if there's time for us to do the exercises, or if you want to do it later after the school has ended. I don't know. Do whatever you feel that works for you. The idea is that we work through these notebooks together so that I explain the core things, and then when you're done, when we are done, then we can, I mean, if you have any question, if something is not clear, we can see them together. Is the font large enough?
Yeah.
People in the back? I see some nods, I guess. That's great. So As I was saying, computer scientists like plagiarism, and I'm partly computer scientist. So what I did was rearrange some content from a very popular web scraping tutorial, which I've also linked here. It's Guide to Web Scraping. But really, online, you can find so much material on how to do things that really I would first go online and then look for anything else. So,
Can I ask something before?
Sure, of course.
Given that you mentioned the ethical and legal issues associated with web scraping, I mean, will academic journals raise an issue with this if we say to them that we use this for obtaining our data?
So yes, I mean web scraping. Web scraping is not illegal, but it might be.
Yes.
So in your paper, if you justify, so we did this and this is ethical, this was approved by a board, or this, we did this, which is the exact same procedure that the other guys used, most of the times is correct.
But we need to send it before to an ethical board before we submit to journal, right?
So it really depends on how much data you're collecting and if you're collecting data about people. If you're collecting data that is already very public, very like, I don't know, parliamentary speeches, if you collected them automatically, well, they are online for anyone to see, so no, I don't think anyone will raise objections to that. So, yeah, I hear some general tips how to be try to be respectful. Website change often, so if the code that works today will not probably work, sometimes will not work. We see this with LinkedIn, right? But here, the code that we use here is very general. We're not collecting data from a specific website. So the basic component of a website is HTML. So HTML breaks the page down, it tags the content of the page into a series of identifiable parts. Okay, so here you have a title, which is actually the thing you see here. Also, my browser is a little different, but it's the thing you usually see at the top with the title of the page. It's enclosed in a tag title. H1 is what we've seen before. It's a header, a very large header, and P is a paragraph. Here we are explaining again all the various parts. And then there is CSS. So someone asked me about CSS earlier. The idea is that CSS is this styling things. So HTML dictates structure. CSS, it basically tells us how the structure looks like. So the graphical stuff is handled by CSS. Again, you don't need to learn and memorize HTML and CSS. Just, there are very good guides for it. So every time you need something, you just look for it. And some of this, I leave you a short guide in this notebook. So web scraping with Python, you do it with a package that's called the requests. So requests is already available in most Python distributions. So if you have Python, you probably have requests. If you don't, so if you try to do import requests or import the other libraries that we'll use in LXML and BS4, these things here, if they don't work when you import them, just do pip install blah, blah, blah. This means it's like an app store, like on your phone, okay? Pip is like an app store. It says, okay, I want this program. Please install this program for me, okay? There is another way of doing this it's another app store that's called Conda. Some of you on your machine will work with pip, some will work with Conda. If you have an error, pip doesn't exist, Conda doesn't exist, you know what to do. You change to the others. And in Colab, the way, this is a terminal command. It means that it's supposed to be run here, okay? But since we are in Colab, you can run it with an exclamation point before. Okay, so this means run this in the terminal. Problems, questions, what the hell is a terminal? No, everything, okay. Yeah, good question. I don't know, I'm not a computer scientist, someone else will tell you. No, yeah, the idea of a terminal is the most basic way of interacting with a computer. Everything that you do when you click on something is a command that you're giving the computer, but under the graphical interface, what happens is that you click on something and the computer basically translates this click into a terminal line command. Okay, so computer scientists, nerdy stuff. So when you see the computer scientists in movies, now they type on these black screens. The stereotype is that they write code in these commands in these kind of terminals, which is the most straightforward way of interacting with a computer. That's it. But you don't really need to worry about it. So how do we grab the title of a page? This is very, very easy to do. So requests is a library that handles, you guessed it. So handles requests, which means what we do, let's try to run it. What we do is we import requests, and this package has some functions inside that can be used to access web pages. So we will not visualize the web pages. We don't need that. We can do that with our browsers, but we will get their content. So we will not see the picture of Facebook, right? We will see the HTML behind it. What I'm doing here is asking, hey, request package, get this URL for me. You paste the URL, see this is a string inside the get method. And I'm asking, get me this example.com page, which is a page that actually exists. Example.com. Okay, this is the page. Very easy. I didn't create this, it already exists. Where is it? So we use get, and then we have this response that is in this res variable. So if I look at the type of this res, it tells me it is a response. Yeah, that's exactly what it's supposed to be. But what does it mean? Well, response is, you don't need to learn what a response type is. It's something that's specific to requests. So requests defines what a Python response is, okay? You don't need to worry about it. But the thing is, this structure exposes the text command. So if I do res.text, res is my response, .text, I get the HTML. Okay? So again, with requests, I send a request to example.com, and my request is get all of it. So I get all of it, and I can visualize it with res.text. And this is a string. You can see that it has the thing here, how do you call this? Quotation mark, like the one single quotation marks. So now we have had the first intuition on how to collect a page, all of it, and then put it inside a variable, okay? So our web page, all of the web page is contained in the res variable. Now what we do is we need to parse it. Parse means to read through it. It's just a fancy term that computer scientists use. So computer scientists are a bit of a weird people. Sometimes they use these words that are like, they try to be funny, I guess. So this library is called Beautiful Soup. Soup, exactly. The BS4 means Beautiful Soup 4. The idea is that the content of a web page are like a soup, and Beautiful Soup helps you navigate through it. Is it funny? No, but they're like this, I know. Sorry, I'll be serious in a second. So you import BS4, and see, here we create a soup, which is an object, a Python object, that inputs my text. So what does it mean? I have my res.text, that is all my HTML that we have seen before. I put it in the soup, and then I can use some fancy commands of the soup object here to get what I want. So it's a processor. Request gets me the data, beautiful soup breaks it down, helps me navigate it. Okay, so for instance, I want to take the title of a web page, and I tell, okay, beautiful soup, select everything that has a title tag, okay? So I put title here as a string, and it says, okay, this page has only one title. You see, this is a list, right? You see why it is a list? Because it has the square brackets. So here we have a list of items. Select will always return a list. Always returns a list. Okay? Because, well, they don't know if there is only one element or 100 elements with that tag. So just in case, soup puts it in a list. So, yeah, so let's put it in a variable. So my title tag, I put it in, so I do this again, and I put it in a variable. When I print this, when I print title tag, I get, again, a list, a Python list with the tag inside. So I index it, and now I have the title. But I'm not interested in a tag anymore. Now I know I have my title. I only want the text. So I take, what is it doing here? So if you print type of something, it will tell you what it does. But and also which methods are available for it. Let me go. Oh no, sorry about that, not the methods. But yeah, sometimes Google Colab changes what it shows you, so I'm a bit confused because this is new. Yesterday, last time I used Colab, it wasn't like this. So the idea, let's resume for a second. So I have my title tag, which is exactly this. It's a string with title, and in the middle I want the text. How do I get the text? I say, take the title tag, which is a list, right? So we index it at the 0. Let's show you. Index it at 0 again, and then I say get my text, get text. Oh, sorry. Get text. And now I have a string. This is a string. And I can print the string like this. Again, I get my data with with the request. I parse the data, the HTML, with soup that has this command select. If I wanted something else, if I wanted a paragraph, I would put select p. That's why you need to learn somehow the HTML. Not learn, but understand where the content is and within which tag it is. And then we remove the HTML completely by using the getText method. Are you still with me? Bored? Slow? Okay. Okay, sure. Sorry for that. So, does anyone need me to go through it again?
Can you summarize?
Okay, sure. I will write some text here, okay? So, first thing, we get the HTML from a website, okay? Request HTML from a website with request package. Everything clear? So there is this command up here where I say, okay, request is my library. Give me this and put it in a variable.
Could you write a real website so that we can see?
It's here.
There's something in this.
Sorry, a real one. Let's try the. Yes. ihu.edu.tr. Okay. So you see it's taking a little more time because this page is longer, so it takes more time to load. But now we have the result here. If I print the text, it's going to be very long, right? Well, not very much. What's happening? Ibn Haldun, it's just cutting it, but yeah. Okay, this is the HTML that your browser sees.
But we will save it as JSON. It's going to be clear.
Yeah, sure. So what Sumay is saying, we will save it in a format that is more easy for us to read. User-friendly, exactly. But we don't really need to save HTML, okay? What we do first is we process it. So we go through Beautiful Soup. Let's go down here. And we say, okay, Beautiful Soup, take my text and process it. So look what Beautiful Soup does. Mannaggia. Sorry for the Italian. So what does Beautiful Soup do? It organizes the HTML into some internal structure. It has some commands. It's some intermediate structure, okay? And from this structure, I want to get my text. So let me show you. I have this res, and res tells me it's a response type, and it is a 200. Does anyone remember what 200 is?
Yes, correct.
Exactly. So res is not actually text. The text is inside there, but what my response is the HTML plus some metadata that I might need. Now, we will not need this, but Python, that's how who wrote the requests package thought it was useful. So when I get the response, I have, whenever you don't know what you can do with something, there is a command you can do. It's called dir, directory. Very long list of things, but here you can see you can ask some things. For instance, what is the status code? So in this case, it will be 200. What is the text? What is the URL? Okay, so this data is inside the response. If you remember, I told you that sometimes the response are JSONs, are like Python dictionaries. And this is a kind of a Python dictionary that contains my text, what I'm interested in, plus some other metadata that I don't care about most of the time. So what we do, so again, this res is a request type object that has some multiple metadata plus what I'm interested in. So what I do is I can use res.text. So text is an attribute of the res of the response object. If I use res.text, I'm telling the request package, okay, take all the structure that you have, where you have the response, the text, the status code, other computer science stuff, and only give me the text. I don't care about anything else. Is it clear? If it's not, I don't have problems. I can say it 100 times. But please, it's important that this part is clear. We move from a structure that contains a lot of metadata, additional data, to only the part that we need. I will assume that it's clear. If it's not, just stop me again.
Just can you please repeat the last sentence you said again? One more time.
More difficult.
That's the worst question that ever asked me. So, what I do with the request is I tell Python to go get me the web page. But the way Python does it is it does not give me the text, because the response is meant for machines. So maybe machines need other information that we don't need. Okay. So what the response does, what request does, is it gives me a lot of information, which is the text, the HTML tags, the status code 200, and a series of other things. But I'm not interested in any of that. So I have to move from a big container full of things I don't need to only take the part, the content that I need. So imagine a response as a big box full of toys, but you don't care about all the toys. You just you want one. You want your toy motorcycle, which is what we will be using to analyze data. So again, response is a box. I only take the part of the box, the text, that I need.
Can you take the picture?
What?
Can you take the picture?
So instead of taking text, can I extract a picture? Sure, we will see that later. Sure. So, but the first thing you do is you extract text. So text here is not text in the traditional sense. It's all the HTML, which also contain images in text form. Okay, so somewhere here there is a university logo. Okay, somewhere there is like a university logo.png. That's an image that we can ask it for. So again, I have the container, which is my response, and I get only the thing I need from the response, which is the HTML. Then what do? I give the part that I need to a very expert scientist that is a beautiful soup, okay? And I tell him, my friend, help me. I have a very complex thing here. Go through it and help me make sense of it. Help me take the part that I need. So imagine you have a book, okay? You have a book and you want to find a very specific information. So you ask someone who is very good at reading to find that information for you. That's what Beautiful Soup does. Reads all of it, remembers all of it, and knows exactly what is where. Everything clear? Okay.
BS4 was the Weeb library, wasn't it?
BS4 is the one that parses, that reads the text.
Yeah, is it the Weeb library or which one?
I don't think I get your question. Is it?
Which library is it like BS4?
It's called BS4. It's called Beautiful Soup. You can import it as import BS4.
So does it really exist, this thing?
Beautiful Soup?
Does that exist which parses the information?
Yes.
Okay. I thought that's something that you made up.
No. That's exactly what computer scientists use to do web scraping. I know this name is silly, but so maybe that's what was confusing you. But yeah, unfortunately, hey, computer science is a very sad job, and they have to, they make some jokes sometimes.
Andrea, sorry.
Sure.
In the Beautiful Soup, you are defining what kind of information you want to extract from the website.
Yes.
So if I want a specific titles from a web portal that about the politics, I can write the Beautiful Soup titles, politics, something like that, and it will extract the titles.
So Beautiful Soup works with HTML, right? Yeah. So this code here, right? If there is something here that says politics, then it will work. But it's most of the time web scraping works by finding the position of what you need in the page. It does not understand meaning. It does not understand that something is about politics. There is no AI involved, like intelligent machines involved. We are just looking through a series of labels and finding in the one that we are interested in. So the first thing you do, like we did this morning, is look at the HTML yourself and say, okay, the thing I want is inside this label here. Inside this, it has been tagged with this thing. And I can use this beautiful soup to read everything and work through the HTML for me. But again, I can ask beautiful soup to get titles, to get paragraphs, to get images, but not to get the image of the university logo, unless there is a tag that says university logo, which is not always the case. But we will see slowly how it works. This code is very long. So, again, let's just close this. First, we get HTML from a website with the request package. Second, we read it with beautiful soup. Okay, my very good reader friend. Okay, so beautiful soup reads everything and helps you categorize things. You can ask it to search very quickly through all the HTML. And then third, we get the information we were looking for with select. Everything clear? Doubts, questions? I know you must hate me by now, but I promise this is the hard stuff. The APIs will be easier. Go on.
Yeah, I mean, can I suggest something? Instead of doing title, can you just show up body, for instance? Because it works better. At least we can see some paragraph. Because I tried it now, and you can also maybe show the real actual.
Exactly. Sure.
So
okay.
Work on body instead of title.
Okay, so we can do body, but not body. Body gives you all the text in the page. Let's look for paragraphs. Paragraphs have this P tag, right? So let's call this paragraphs. Oh, first, actually, let's avoid let's avoid confusion. Let's do it again here. No, sorry about that. So let's say I want to get all paragraph, right? I do soup. He knows it. Again, autocomplete. Soup select P. This will be a list of paragraphs. Again, only one paragraph. For some reason, there is only one paragraph in the web page. Can you understand what this means? What does it mean?
It's about cookies.
Oh, okay. Sometimes there is a problem with this. So most of the times you will not have this issue. This is very, very unusual issue. But yeah, to work around it, most of the time what you do is ask ChatGPT. There is some way to parse through it and get the way. So again, when you get the paragraph, this is not a single paragraph, it's a list of things. So what I want to do is index it to take the first one, right? Because there is only one, I want to get this. And then what I want to do is get the text of it. Oh, get text. So first we select the paragraph, then we index the first one or the second one or whatever, and we get its text.
Can we go little like specifically from the website, especially if we want to use for a research? Can we say, for example, number of total students from this university, something like specific, so that in a way that will benefit us for what we are intending to do?
Sure, sure. I think we can. Let me see below. We have something. We have something later, but maybe we will do that earlier. Let me see if. By the way, don't worry if this looks nasty. It will make sense sometime. Should be this one. Or maybe that one. Yes, exactly. Okay. So I will show you. There is this this exercise, this page here. It's called Books to Scrape. It's kind of like Amazon, but you can't buy anything in there. It's just a catalog of books. Okay. So what I would do at the beginning, I've never seen this website before, never scraped it, is a right click, inspect, and look at the things, right? I go over something and I see where it is that it highlights my thing. So the content is inside this div tag, but I want to go deeper, right? There is another div here. There is this, so if I want the bar in the left, I can just collect this aside tag. I do select aside, and I will get this sidebar. I don't care about it though. The real content is inside this other div. Div is just a fancy word of division, container. It's something that contains something. So here we have a title, you see, I got over it. It has a class called the page header section action. So if I collect class page header action, I will get actually what these all products here. But then I want to actually get this. So this is inside a section. So it's very boring, right? You have to manually go through, understand exactly the kind of tag that you are looking for. And this can take some time. Again, inside an OL. Oh, okay. So you see, these books, each one of them is inside an LI. LI means list item. Of course, makes sense. And every LI has some properties inside. So we have the product pod, which is basically this box, and inside of it, then you have also the information that's below it. So here it's product price, for instance. So if the people who built the HTML, the website, are kind enough, they were smart enough, they probably used very simple, very clear tags. But this is not always the case. So if you feel like this is very hard, don't get discouraged. This is supposed to be hard just because websites are very different from one another. They're very diverse. So it takes time to get used to it. You have to do multiple times before you actually feel like you are proficient at it. I've been scraping websites for years and I feel every time I have to learn something new. This is normal because the websites, again, they're very different from one another. But what you will mostly need, I think, is APIs. So this is just the hard part because before we get to the simpler part. Don't get discouraged. So what I'm doing with the code, exactly. So I put, this is the URL of the web page. Okay? So,
May I ask something?
sure.
So with Ibn Haldun website, we only could reach one paragraph because the paragraphs on that website are coded differently. Is that?
You're asking of the university website, right? So, you know, the content of some pages is dynamic, which means that it changes. It has multiple layers. You know, when you get into a web page, the first thing you see is the cookie acceptance thing. I don't know if you're familiar. It's a box that asks you for permission to use your data. Some things in the web page can change while you are using it. Some images might slide. I don't know. They change sometimes. So this library, this request that I'm showing you, is very simple and works mostly for pages that don't change very much, that don't have many dynamic things, scrolling parts, moving things around the page. If a page contains mostly text that is fixed, like an article, then it's very easy to collect. But you know, university website has a lot of parts, has a lot of not advertisement, but you know, news maybe, news that move, or some things that change in the page. Sometimes you could have, maybe your connection is not very good, and so not all data gets to you. That could be something that happens. How do you check for it? Well, you could do multiple times. But in general, it gives you like a response. It tells you like status code, blah, blah, blah, a number, data incomplete. So how do I, let's do something. So this bookstoscrape.com is my website, right? This one. So if I look at the URL at books to scrape, where was it? At books to scrape, the URL is, it gives me index.html. Index.html is a convention that says the home page. Okay? Let's see if I can. No. I was hoping to do something clever. So there is a way of when you go, what is it again? Yeah. So this is all my books in my web page, and this page has multiple pages. You see, one of 50. So what I do is I have to click next every time, right? Next, if I want to go through all of them. So there are more advanced packages that will have like a kind of a bot that clicks next for you. But that's very advanced, that's very complicated to set up. Needs to install a lot of programs. It takes time. Probably if you need it, ChatGPT can guide you through it. But for this class, let's keep things simple, which again, it's most of the cases. How do I navigate through all these pages? Well, somebody noticed that that's the why we need some working first before collecting data. That's why collecting data with scraping is a bit hard. Somebody noticed that when you change the pages, the URL changes as well. And it becomes /catalog/page dash a number. Page 1, page 2, page 3, page 4. Okay? So this is part of why this is hard, is because it requires you to look into things. Again, this is the hard part of data collection. The other part is easier. So what I can do is tell my program, okay, I know that the URL is formatted like this, okay, with a number here. What I can do is go to page 1, then change this number to 2, go to page 2, change this number to 3, go to page 3, and so on and so forth, and collect all the data. So what I do, let's go very easy. So this is a trick in Python. Don't stress very much over it. When you have some multiple pages, you can put these curly braces in a string and then use format, which means put what I put here in the curly braces. Does it make sense to you? Let's go back for a second. So I have my URL, and I notice that my URL changes, my address changes every time I change a page. So the URL contains the information on the page I'm looking at. So a way of going through it programmatically, automatically, is starting with the first page, and then I can do go to page 2, put the 2 in there, put the, 50 in there. Okay, it's just a way of going through the pages.
So there is no way to order the 50 pages to be scraped at the same time?
To be seen at the same time? No. Unfortunately, since you can only look at one page at a time and the website gives you one page structured in that way, you have to work around it. But what you can do, exactly, beautiful. What you can do is for, Gemini is very good. So for n, for a number in the range between 1 and 51, remember this is excluded. So from 1 to 50 in human terms. What I want is my base URL formatted with the n inside. What does it mean?
All the pages.
All the pages. So what I will do, I will say, now I will write comments and you will see that Gemini will do it. I will visit the page. Come on. Come on. So Gemini is done today. So what we have learned is with which package we get the page. Good. Request. Exactly. So response equals request get that. Base URL format n. Then what would we do? We put it in a beautiful soup, container. Okay, so beautiful soup is the organizer of my container. Don't worry about this. We will talk about this in a second. And then what I do is exactly. So what we could do is select soup.select something, but we don't really know something what to select yet, because you have to decide which tag in the web page to look for. What time is it? But Gemini is smart because I wrote product pod somewhere in the code, so it knows that we're looking for that. Let's go back to that. I'm show you what I mean. So here, where is it? Okay, you see that my book is contained in this article here, and it has a class equals product pod. Okay, class is a CSS thing. That's why you don't know it yet. Class is a way to organize things in CSS, to have different things do different parts of the website have the same style, the same color, the same thing. So everything that has the class product pod will display a book with the stars, with the title, blah, blah, blah. And the HTML, what it says is where is it? Whenever you find something that is it has the class product pod, it has to contain all of those information, and so we know that's what we are looking for right now. Let me, yeah. So let's do just one page for a second, okay? I will, how do I do that? So I commented this just to this will not be printed, okay? So let's work with just one page, okay? I want the first page, right? So this needs to be a string. I know it can be a number as well, so we can just put 1. So now I get, where is it? Now I get my response there. So when I get my response, again, a response 200, blah blah blah. What should I do? I should get the text, right? res.text.
If you were not if you're not allowed into the website, then you would get 404 or
403. 403 means you're not allowed to view this. You cannot ask me this. 404 means I could not find it. So maybe it don't have connection or the page isn't available at the moment.
So when you see 200, you see it's a pass.
It means everything is correct. All the data you requested is there. So you see, now we get the text of this thing, but this is the text of the whole page. Okay, so there is more text here that it's not showing, but it has collected it. So what we want from this text is not all of it. We want to pass it to Beautiful Soup, right? So XML, what is it? We never talked about this, right? Never heard of this LM, blah, blah, blah, LXML. So it is just, bear with me for a second, it's just a performance thing, which means reading through the web page is very slow, and we're saying, okay, use the fast car, okay? Don't use your normal speed, use max speed. I ask my friend who is faster than you at reading. That's it. I'm just saying use a different engine, okay? And indeed, it's almost instantaneous. It reads through all of it. Then I want, what do I want? We said that I want the product pod class. So I want product pods, and Gemini says product pod. Do you notice something weird here, apart from all the computer science stuff? So when we do select, when it did select before, we were saying select title. Now we do select dot product pod, right? So this is just syntax. You don't need to memorize it. It is explained up in the notebook. Basically, the thing is, if I use select something, I want an HTML tag, the thing that have these brackets here. If I use a dot, I want all the HTML elements that have the CSS class named, notice in this case, name product pod in our case. So again, you don't really need to memorize it. If you politely ask Gemini, they will figure everything out what you need to do. The only thing you need to really do is find the specific tag or HTML class, CSS class that you need, and then tell Gemini, okay, I need from this page, select all the things that have this property. this tag, this class, blah, blah, blah. Here it's a very quick cheat sheet. So to give you some ideas in general, for instance, I want to like some indentation, all elements that have this tag that are inside another tag, something like that. It's just syntax. Again, you don't need to learn it. Nobody knows everything of this thing all in their heads. Every time I have to do this, I go back and read how to do it. By the way, this code is already in the drive, so you can look at it and play with it. So what I do is I select .productPod because here product pod is a class. It's not, if I said article, I would not need the dot. Is this passage clear? It's just a syntax thing. The way the beautiful soup wants us to write, to ask for their magic to happen. So silence is approval. I was told yesterday by a very good guide. Okay, so I get the product pod, soup select product pods. What is it? It's a list of a lot, see, it's a list of a lot of things. Then I want something simpler. I want my specific data, right? So now I'm sure that I have all the product pods in the first page. Let's not worry about all the other pages. Let's first focus on one, and then once you figure out one, it's just a for loop, and do it for all the pages. So let's go and do it easier. This must be cleaned up before we move on. Request that something is wrong here. Okay, I will clean this up anyway. So the products again are in the thing we did here, right? So if I want one product pod for one book, I do product.0, the first one. Product square bracket 0. What type is it? It's a tag. It tells me, okay, you took some HTML thing and its content. And you know that last time we did get text, right? If I do get, yeah, but I also did another mistake. I didn't. Okay, so let's print it as for a second. See, I light in the blah, blah, blah, in stock, add to basket, okay? So, but I don't need the text right now. So what I wanted to show you is there is this attribute, what was it? Example. So example is my tag, right? With all the information in it. If I do dot attributes, I know it is a class, it has as class, it has product pod. What I wanted. Let's see. So let me find a way to phrase this in a simple way. This is another container, right? My product pod. Sometimes in computer science, when you take something and you divide it into parts, we call the parts children of the big thing, okay? So what you can do is use the dot children attribute to see, again, another way of seeing what's inside this. I know that this may be too much for some of you. I get it. For instance, the first element is just this. This means go to the next line. It's a blank space. From this example, if I want all the, if I want to, okay. If I want to check if my thing has 3 stars, again, let's go there. If I want to check if my thing has 3 stars, first of all, this is, it was not page 1, right? Page 1. I liked in the, so this is exactly the thing that we collected, right? I liked in the attic. And it says it has 3 stars. So by inspecting this, we find out that 3 stars are, again, it's always a game of how is the data I'm looking for structured. So if you can write on a piece of paper, you can write which tag you are looking for, which characteristics it has, so which class, which blah, blah, blah. Then you can, okay, ChatGPT, Gemini, or other LLMs, please help me. You are an expert in collecting data from the web. Write a code for me that will go to this website and look for this class, this, blah, blah, blah, this, all the things that you find out by exploring this part here. Again, web scraping, that's why it's hard. That's why they invented the APIs, okay? Because people don't want to do this. This is very complicated. People who work this get $100,000 a year. I wish I had that money. But yeah, people who do this, you can see why this is hard, because it's very tedious. Things change all the time. You can get lost. Let's, where was it? Okay. Let me just, okay. So by exploring this pod, so this book here, we see that it has 3 stars, and that all elements that have 3 stars have this thing, this class, star rating.3. Why? Because the programmers of the website said, okay, every time a book has a rating of 3, we put this thing here, star rating 3, and the browser will display 3 stars out of 5. Okay? So if I want books that have only 2 stars, I can do example, select, star rating 2. And I will find nothing, because that book has only 1 star, 3 stars. Is it clear? Do I need to go back? Sure. Exactly. Okay, so let's go just back here. So we selected all the products, and we have it here, but now we're working with example, just one.
We selected a product.
Exactly. If I do select product pod, and then I do select star rating.3, select star rating.2, where is it? I will get all the 2 stars book. Okay, it's just that we're working with one piece. Once you, yeah, no problem. Other questions? I saw a hand somewhere. Someone has any issues? Too fast? I get that this is too fast, but I promise the next part is way easier. Gone. Sorry, I am very...
Can you try to do this again? A simpler example, for instance, a title of a line. Can you use like a, I don't know, a keyword and see how many times the first keyword will be something?
Sure.
I don't know what the recipe for me. I need this one. Need to have it a bit more simplified.
Okay, I get it. Okay. So the thing is, like, we need a very simple website. That's why I was working with example.com, because this is just, if I do inspect here, where is it? Blah, blah, blah. Inspect. This is a very simple HTML, right? You have a body, container, 2 paragraphs. So you see that there are 2 paragraphs. There is one learn more and a one domain, blah, blah, blah, this other text here. So if I do select P, select paragraph, I will have a list with 2 items, this and this learn more thing. Let's try to do that. Let's go back to the top. Okay, from here. Let's go back to example.com simply because it's a very easy website to go through. It's a page. So the text, we already know this, where is it? This HTML. It doesn't show me properly. If I put it into Beautiful Soup shows it to me in a good way. Okay, it says, okay, there is the HTML tag that contains everything. There is a title, example domain. This is the title of the web page that you see here, example domain. And then there is all metadata, how large is the web page that I'm looking at, something like that. But what we care for is this body here. The body always contains the information that you want, but it's nested inside other tags and other tags and other tags. So the more you filter, the easier it is to get exactly what you want. So here, for the other time, we looked for title, right? Title, there is only one title, of course. But if I want to look for paragraphs, there are 2 paragraphs. It's a list of 2 things. The first is, this domain is for using demonstration, blah, blah, blah. And the second one is another tag that is a link, learn more. And we have a link here. So when I do select, maybe I did it below, exactly, all paragraphs. So if I want the first element, I do all paragraph 0, and then get text. Is it any clearer or more confusing? Is that a raised hand? No. Okay.
How do we know the short forms for paragraph? Like, for example, you said it was P. How do we know that?
Most of the time, there is this website. So, okay. The first thing you should do when you want to do web scraping is go to the website you want to look at and look at the HTML. So by looking into that, you will see, okay, my content is generally inside this P or inside this title, blah, blah, blah. Then online it's full of resources to, if you are interested in what that means. Like if you need to collect something, you don't really need to know that P stands for paragraph. You just need to know that your data is in a P tag. So that's what you want. Sorry, did I sound rude to you?
Yes, yes. So I have to go and look at the HTML and
Exactly.
the write-up they use for that.
So all paragraphs, I select all paragraphs with P, I get the first one, and I get the text. So I will just very briefly finish the thing with the books to give you a minimal running example. After that, I promise, I swear, everything else will be, you don't even really need to look at the code anymore. Okay? So this is all the cases where you have a complex website that does not have an API. If a website has an API and you have access to it, then you don't need to explore all of these things. I get it, it's very hard, and probably you can find some computer scientists that can do that for you. They don't like it, but they will do it. Nobody likes these kind of things. It's very annoying because you want a machine to do things for you, but you have to put in so much input, so much energy to find in the right tag, blah, blah, blah, that it's not really a good, something that computer scientists do. So, if I want to look, so again, I was saying that my product pods, so my books with their content, they have this property here, this class, star rating 3, if they have 3 stars. Otherwise, they have star rating 2, star rating 1, 4, or 5. So if I want to get okay. Let's look at this. Okay. So this is already doing all the work for us. Let's say I want to get all the 2-star titles in all the website, the full website, all the pages. What I do is, I do this multiple times, okay? Let's forget about the for loop for a second. This just means I visit all the web pages. I get the URL, so I write the URL with the page, right? This looks like, come on, tell me. Sometimes it doesn't do it. But basically, let me go back. This. Okay, so this scrape URL, it actually looks like blah, blah, blah, blah, blah, blah, page something. So we say, hey, request, give me the page that is at this address, this URL. Then I give it to Beautiful Soup. Note, I give the text to Beautiful Soup, the HTML to Beautiful Soup, and I tell him, read it fast, XML. And then I say, okay, take all the product pods. Take all the things that have this, that are enclosed in this box. So every box in every page. So I do another for loop. So for every book, so for every product pod, if there is at least one star rating 2, so here I'm saying this is just a probably overcomplicated way of asking it. If the book, the book structure, okay, the product pod, that box, contains star rating 2, what will happen? That select will return a list of one element. So the length of the list will be more than 0. Different than 0. You can write it like this. if there is at least an element, and we know it has to be just one, right? Because this is just a box. Then we do take the title which is in this position. Book, select A, select 1, select title. So index 1, index title. So what happens, don't worry if you don't understand why we go 1 and title. It just means that that's the position in the HTML that we discovered that our data is in. So it's the result of your manual investigation. So now we have a 2-star titles. It's still collecting, see? Still collecting. Takes some time. I hope, okay. And then we have 2-star titles. Everything in here. Very quickly, let's run through it again. And then I promise everything will be easier. I swear. If I'm not, you can throw me a knife and never let me see my home country again. I'm fine with it. I'm trying to run away. So, we have this URL that has multiple pages. So we want a way to move through all the pages. And we discovered by manual inspection that the URL changes every page we visit. We get the page, each page, with the get method of request. And then we pass this to Beautiful Soup. So we create soup equals Beautiful Soup rest text. We put it in this soup. And we say, okay, Beautiful Soup, give me all the product pods. All the elements where we, by manual inspection, we found out that our data is stored in there. And then we discovered also that in these pods, the books that have 3 stars have this class here, star rating.3. So if I wanted star rating.2 and 4 or 5, I have to use the same syntax. Then we also discovered that the title of the book is inside a tag. A tag just means there is a link somewhere. And it has a title in it. So let's example. So this is a link. See, there is an A tag. And there is a title here. A light in the attic. So what I do is I only care about the second part. This is a list of 2 elements. I take the second element. And then I say, okay, of this second element, give me title. I think I can also do .select title. Why? Why not? Select .title. Why not? Something wrong here. Anyway, if that doesn't work, again, title. There is always a way. Ask Gemini just in case. So to put it all together, we get the URL with the page number. We visit the page number. We ask Beautiful Soup to look through the page to select what we are looking for, and then do it programmatically for all the books. And that's it. Let me see.
Do we need to memorize the steps in the codes?
And memorize what?
Those steps in the codes for each step?
So I think memorizing steps in web scraping is pointless simply because every website you scrape is different. But there are some general, like you always need to visit a page with the get request, so requests.get something. Then you always need to, most of the time you need to read through it with Beautiful Soup, and then you need to find a way to tell Beautiful Soup what you want. And that's it, basically. But where the things are stored in the page, it has to be you that look around and find that out. Did I answer your question, or? Okay, that's great. So, if you feel confused or tired, I get it. The first time I scraped a website, it took me a week just to understand what the tag was, because the page kept changing. So again, don't get discouraged. So I get that now, maybe depending on your project, maybe you need web scraping. If you need it, we can talk about it and work it out together. But most of the time, that when you're doing actual research outside of this winter school, if you have time, do it yourself. A computer scientist will probably tell you he can't do it right now, but anyway, they will do it for you, no problem. The thing is, it takes time to look through the stuff, and we don't like it because we would like machines to do it for us. One thing you could do, let's see, let's try this. Bookstoscrape.com. One thing you could do is go to ChatGPT and do like this. Let's try if it works. I never tried it. Try to copy this some way. No, doesn't work. Come on, give me something. Blah, blah, blah, not here. Come on. No, it doesn't do it. It doesn't do it. But, okay, so I go with body, copy, great. So I copy everything. Let's see if it copied everything actually. Okay. So I copied the whole page. I go to ChatGPT and I say, okay, and I say, so normally I would ask it with a very long prompt and say, you are an expert in web scraping, blah, blah, blah, but let's do it quick, okay? So I'm teaching something and doing the exact opposite.
Appreciate it.
But at least I hope you appreciate the honesty. So we paste the whole body and say, here is HTML from a page containing info on books. Write Python code to collect all books with, what do we have here? Let's see. Do we have prices? Okay, that cost less than £50. Where is it? That cost less than £50. And then I would ask, write very simple code. Otherwise, machines, they tend to be complicated. They don't know that you're not very good with Python. So, but if you ask them, write simple code, do not overcomplicate things, it will do it. See, beautiful soup. So we say put the HTML here. So you see here it's using, here we will put LXML, which is a very fast thing that we used. So it uses something else. We learned a new command here, find all. Find all elements that have an article tag and a class product pod. It understood by itself. I didn't tell product pod. It read the HTML.
Would it work if you only copy the URL on the page?
Let's try. I'm not really sure because sometimes it says I cannot visit it, I cannot access it. It does? Okay.
Then you copy the HTML.
Then you copy the HTML and it works.
It works for just one page.
Okay.
If you have more than one pages, if you have to click on the links on the page.
I see.
Even cloud, it doesn't work.
So there is always going to be some thing involved. So you see, let's try. Let's go back to the okay. Now I'll say the URL looks like this. Write code, adapt the code to work for all pages. Okay? I'm saying, okay, this is what my URL looks like. Now, do it yourself. So, there is one computer scientist in this room and he's dying right now, okay? Because this is exactly what we don't teach computer scientists to do, ever. But, I mean, I get. And again, this thing can be still complicated to some of you. But see, ChatGPT does response res equals request.getURL. So it gets our thingy that we wanted before. And then it checks for the status code. That's very clever. I didn't do that. It says only if the response status code is not 200, this means different from 200, then go away, stop it, break, go to the next thing. Okay? So that's a clever control, which we didn't do before. If for some reason we couldn't find the page or access was denied, we couldn't actually work with it. So ChatGPT was clever than me. Well, it's a machine, so what can I say? So everything clear right now?
Yes.
Okay. Don't worry about the while true. We'll get to that, but it's not really important at the moment. So we pass the text of the response to the beautiful soup thing. Then we do find all articles that have a product pod class. For each book, blah, blah, blah. Go and find and do. And indeed, what does it do? Look what it does. It looks at the title, takes the title. Look at the price text, and it finds out that it is text, right? We want a number because we want to see how large is this number. Recall we asked for price that is less than 50. So it takes the price, strips the currency, and just says and converts it to a number, a float. Float means floating point number with a comma, right? With a decimal point. And then price, blah, blah, blah. And if the price is less than 50, like I asked, go on. Let's try to go. Okay, let's try to go there.
Why do we need to write price color in there? Go back because
Yeah, sure.
price color.
Price.
That's how they call the class.
Price color, yeah. So the ChatGPT found out that the text of the price is inside a paragraph that has the class price color. okay? Because price color is a tag that someone coded manually to say, okay, everything that is a price, I will give it a price color. Okay, I want the price to stand out. So it found out by itself that there is this kind of price color, and then it gets the text, and then it converts it to a number. Let's see if it works. Maybe it doesn't work, right? And indeed it doesn't. Cannot convert string to float. What does it mean?
Some prices are not, or most of the prices are not floats.
Or?
They have dots.
That's a good one. So what happens here, if you see, this is one of the prices that it found out. Okay? So one of the prices it found out has this something. Yeah, this something that is not rendered properly.
Andrea, would it work if you didn't write floats? Would it work then?
It would work, but then we could not compare it to the number here. Because to do comparison, major, minor, blah, blah, blah, you need to have a number there.
So if we just erase that one too, would we have all the information?
So if we do this,
for books that are not below 50.
so if we just want all the books that have a price, then it does. It works. If I remove this, no. What? Where is it? Because I forgot this. Then it will work. And you see it's still computing because it's visiting all the pages. We don't save anything right now, so we don't print anything, so we will not see, but it's moving through the page. Let me stop it. And indeed I stopped it. Okay. So one thing I can do is, okay, ChatGPT, some words have a weird character, some prices have a weird character. But ChatGPT will not be able to deal with it because it really depends. Maybe it is just one thing. So sometimes, again, manual inspection, that's a very hard problem. Test, try again, trial and error. This thing is hard. And there is not a unique way to deal with it. Sometimes some platforms, on purpose, they put some errors there so that scrapers break. So, how should we go? I think, when was I supposed to stop? I've been asked a few times. And the reason, the answer is, I don't know. So, it's probably legal. Depends on the website that you visit. Depends on the country that you're working in. It depends on a lot of things. I mean, here it's just a demonstration, so we should be fine. But this really doesn't, and most of the time, if you don't make money with the data you collect, you'll be fine. Especially if it's for research purposes. This is not legal advice, once again, but this is just what people that are more experienced than me told me, and that's what I'm telling you. Another thing is if I'm trying to scrape something and there is no API and there is a block that does not allow me to scrape it because it says I tried and failed, what can I do? Nothing that I know. If there is no API, if the scraping doesn't work, probably you're best off asking the website owner directly, which is probably through emails, and so it can be very hard. Other thing, I understand that this thing here is probably one of the most complex things you've seen so far. And again, that's because it's one of the hardest things in computer science. Okay? Navigating through websites automatically, something changes, everything breaks, right? A lot of problems, it needs a lot of tinkering. That's why APIs are so powerful, because we have this standard of communication where we just kind of exchange a well-formatted response. I ask precisely for something and I get exactly that without having to look through web pages and blah, blah, blah. There was something else that people ask me about, but when it comes to mind, I will say to you. So just to go back to the Jupyter's, to the Colab notebooks. If you want to work together with me, as I do this, your best way is not to open the file from the browser, but just make a copy of it. Otherwise, you will be working on something that will not be saved because you don't have rights permission. You cannot save the things. So what you can do very quickly is, again, this is in Italian, but hopefully you can guess, is you can say download.ypy something. Or you can go back to the thing here and say create a copy or of something. There is kind of a way of doing that. If you work on a copy, you can save it, edit, and blah, blah, blah. If you work on clicking like this exactly, my changes will erase your changes. So, again, this, sorry. The other question is, if web scraping is a bit, in a gray area, can I publish my results? And the general answer to that is yes. In my experience, reviewers tend to frown when they see the word web scraping, because nowadays with LLMs that have ingested a lot of our data, this word web scraping has become nasty, no? Some people think it's a bad thing. So first of all, let's package it cleanly. Let's say we collected our data with Python and we ran some safety checks. Maybe if you have an ethical board that can approve that would be nice. In any case, write a small section in your paper with some ethical considerations. This is very, very important. Second, if something has an API, most of the time it's better to use the API also to publish. Because if a platform provides an API, not using it and scraping the platform probably is breaking terms of service. So I don't know of any editor that would reject a paper because it breaks terms of service, but maybe in your field it's different. So it makes sense always to, first thing is to collect some data is look for the API. Always. How do I do that? Google is your friend. I want to collect data from YouTube, right? So I say YouTube API. Okay? So I know it exists, right? This is a page from Google, so I know that there is a data API that I can use to extract data. The second thing you have to do is this API, did someone wrote some program to use this API in Python? So YouTube API, Python, right? So there are some Python quick start, right? So Google itself is telling me how they want my code to look like, what they want me to do. Okay? For instance, here it says I have to pip install Google API Python client. Okay? So this is the library if you're interested in YouTube data that Google would like you to use. There are other options, but this is the official one. Okay? So the second thing, and the reason why code is not that important in this session, is that the longest thing in the longest process is applying for access to the API. So YouTube will give you access instantly. It will not take days or months or weeks. It will give it to you instantly. But there is a procedure you should follow. You have to go somewhere, click, ask for, build a project, blah, blah, blah. There are some steps that Google will tell you. It's very easy. It's not hard. It's just, click through pages. If you look at the various notebooks that you can see here, all of these include the rules that the platform wants you to do to get that data, to apply for that data. For instance, very, very quickly, if you want to collect data from Blue Sky is something like Twitter, okay? So it's a platform that's supposed to be works like Twitter. The first, thing you can do is install the Python client, the Python library that is used to work with the API, and then get your credentials. So we know that the Python client, the Python library that works with Blue Sky API, wants your email and password. You're not giving it to them, you're saving it on your machine, but that's what is required for it to work. So you need to have an account. You need to be using the service to use the API. So in this case, I would put my Blue Sky username here, my Blue Sky password. Be careful, here you are putting your credentials, your password in plain text. If someone sees it, they will know your password. So always use a second account if you can. And then everything else, then it's all documented. You go to Blue Sky Documentation API Python, and it will give you already scripts that you can use, copy-paste, to use that. So again, this is how the Blue Sky one thing looks like. It's very easy. It's like this is the client, is the thing that we use to interact with to send our commands. Login because we need to access the service. And then, for instance, the timeline is accessed with client.getTimeline. And limit 5, it just means just get the first 5 posts that I see. That's it. Sorry about that. Of course.
I'm sorry if it's a stupid question, but
No questions.
Of an API, or the difference between a website that has an API and one that doesn't, and how does it affect Webscraping?
Okay, good question. So the API is just a standard, something that we all agree on, of how you can interact with the data that is in the platform, in the website, okay? So if you want to make an app that is a different app for Facebook, I don't know, or your own YouTube app with no ads, okay? You can do it by interacting with the API. You can build your own separate app and use the API behind it. So the API is this kind of toolbox that the platform is providing you to access the data in a variety of ways. You can use it to collect data, to post something. So for instance, the API can be used also to create a bot. So if I want, for instance, there is a bot on Blue Sky that shares papers about network science every 5 hours. Okay, every 5 hours, this bot it's a profile, it's a user account that looks to an archive and says, okay, these are papers about network science, let's post them to Blue Sky. Okay, this can be done always with the API. Web scraping is instead something completely different. We're treating it in the same class, but it's something that at its core, it's different. So, what did we do with Beautiful Soup? We read all the HTML code and then extracted parts of it, worked with the pieces in a large document. So you can think of web scraping as reading documents, while APIs is just talking to the data. let's say, so it is something different. So the web scraping requires you to visit the pages, to read the document, and find the parts that you need and download them. While the API is just, you're asking directly to the manager. And the manager is saying, okay, you can take this data and use it. Does it make sense to you? Did I answer your question? That's great. So, again, the code for most platforms is very easy. So, unfortunately, you have to learn a new library for every platform that you want to collect data from. There is no universal API client. But luckily for most platforms, this is very well documented. There is a lot of code online. There is a lot of text in human language that you can read and understand to make it work. And what this means is that LLMs know that as well. So LLMs will know how the YouTube API works. So as we saw before, we saw that we need to install this Google API Python client. Okay, this is just to have on Colab to have our library that can interact with YouTube. Then it's the, I would say, not hard part, but the tedious part. You only have to do it once for every platform that you're interested in, which is to get the API key. So the platform needs to verify that they are giving the data to a real person. They have to be able to trace back to you, to send you an email if you're doing something wrong or illegal. In principle, you can't, but they want to control, they want to know who is using their data. So what you have to do to get an API key in the case of YouTube is these steps here. You go to the Google Cloud Console, which is a website where you log in with your Gmail account, create a new project, and search for YouTube Data API, blah, blah, blah, enable, and get the credentials from there. Let's do it together. But again, this is just an example of an application process. If you want to collect data from TikTok, the application process lasts at least 2 months. You ask for your data today, in 2 months, maybe they will give you access to their data. So if you go to the Google Cloud Console, so yeah, sorry, this is in Italian. Let me see if I can translate it somehow. Traduci e non in italiano. I should have thought about this. Sorry about that. Let's see. Google Cloud Console, new project. There is a blah, blah, blah, translate somewhere. So there is no possibility of translating?
You can use it from user preferences language.
Let's see. Shortcut, advanced, general. Previews, before quitting. Blocks. Where? What? Okay. Like I have to change my system's language. Let's see the US. Oh, that's the thing I was supposed to do. Sorry about that. I know that this is a bit tedious, but we'll. Okay. I have to reboot my computer. Well, let's do it. So again, the main thing here is find out how to apply for API access. Once you do that, the remaining thing you need to do is, if you know what kind of data you want, so you want, in the case of YouTube, do you want the titles, the descriptions, the comments? whatever you want, there is a website somewhere that will tell you how to do that. And this is, most of the time, it's the official documentation of the platform telling you, hey, listen, you want my YouTube video titles? This is there is a client.get video title, something like that. But you need credentials, once again. This is not, okay, this is, sometimes it's in Italian, sometimes it's in English, that's how it works. Sorry about that, let's just.
Should we just agree to the terms of service and continue?
So that's the one of the problem. The thing is, if you're using the API, you are implicitly agreeing to the terms of service. So if you don't want to do that, you cannot. You have to find someone else to collect the data for you. What you can do if you, what you can do is maybe you create another account that you will delete after you get your data.
Yeah, because these are our institutional accounts.
Ah, I see. I see the problem. But no, it's still in Italian. What the hell? Sorry about that. Let's see if I can. So this is something that we could remove. Nah, still in Italian. Has to be done. So to save on some time, let's keep it simple. Translate to English. So maybe what you see now is different from what you have on your machine, but hopefully it's a good enough translation. So, this one? Yes. There is somewhere something that says new project or YouTube data API. So somehow APIs and services should be here. So here I can create a new project. There is somewhere in here where you can create your new project, and your credentials will be in the credential webpage. So I shouldn't probably show you this, but here is, so this is what I created to test this before showing it to you. Somewhere here is some ID that I can use to connect. So this is API key 1, for instance. The API key 1, if I click on show key, it will show you my key that then I can input in the program to actually make it work.
Can you start again from the beginning when you go in and paste?
Yes, no problem. Let's go the beginning.
Can you go way back to the website, please?
Sure, did. So the first thing you can do is also Google YouTube data API v3. This is what it's actually, YouTube data API. Okay, here it will, again, Italian, but here it will tell you how to do that. To get started, introduction before you start. So it says you need to have a Google account and then create a project on the Google Developer Console. Okay, so we go to the Google Developer Console, which is this thing that we were seeing before. And then there is somewhere, maybe this looks different because it's...
I think it looks different on our computers. Because I don't see the screen that you're seeing.
Access from the link.
I think okay, let's do like this. Because I think it's because I already have some keys. And so...
I see something like that, yeah.
Okay. So yeah, we need to accept this kind of thing. And now probably you see this, right? It says to visualize this page, you need to select create a project. So you click on this create project here. So what they want is a title. So there's a demo, something like that. YouTube API. Organization, no organization. So it is not affiliated with. Why doesn't? So apparently it needs to be. And then you basically click on create. Whatever. What is happening here? So I think it's because I'm using an institutional account. Let's try to do it my personal one.
It doesn't work with institutional account.
Ah, I see. Which is a good thing, I guess. So you can create a project. My project demo. Okay. No institution, create. Okay. So you have this now. You should have this now. What you do is you go into credentials, and there is nothing in here. There is no API key. This is what you're trying to look at, right? So you'd click on create credential. Again, sorry about that. There is somewhere here, create a new credentials. And what you want to look at is API key. The key to the castle, the key to the API. They will ask for some information. So what kind of data do you... So first it will ask for a name, okay, of the key. This means API key. API key number 1. Then this is basically, I'm saying, do I need my API only to work on iOS devices? No, we just need everything to work. So we leave it here at none, no restrictions. And don't limit the key. So if I'm creating a key to give to someone else, maybe I want to limit it in case that person messes up, and then I am the one who will, have problems with it. Again, if most of this doesn't make sense to you, the only thing I want that sticks with you is there is always a process, or most of the time there is a process to apply to an API. It may not be explained clearly, but there is a way.
It's limited. Recommended them to limit.
Yes, but we're bad scientists, so we will not do that. So somehow, here I have my API key. I will show this to you. This is how it looks like. It's a string of characters, right? And then you copy it, and you can paste it in, where is it? Yeah, API key. You see, this is the thingies, I only remember in Italian, sorry, the quotation marks. Single or double, it doesn't matter. So you put it here, and basically what this does is, maybe I should install this first. Basically what we're doing now is we're saying, okay, Google, you give me the keys. Now I can use the keys to interact with the website without visiting the website. We are not going physically to YouTube, opening a YouTube page, scrolling through it. No. We're just saying, okay, YouTube, you have a big database. Give me all the things in that database that look like the thing I want. So this is what we're trying to do. We are trying to connect and successfully connected to YouTube. So now YouTube knows that there is a computer here in Turkey with my credentials that is trying to get data from them. And I'm a verified person because they approved my work, my project, exactly. So, to find your first video, if you go on YouTube, if you've ever used YouTube before, you know that the URL of YouTube, how it looks like. There is this watch, and then there is a kind of a series of string of characters. This part here after the equal sign is the ID of a video. It's a unique identifier of each video. So if you want to get a video, you paste it here and then say, okay, YouTube, give me your videos and give me some statistics and some data from this ID. So how do I know why this code works? Because I've read the API documentation, the Python API documentation, and it says if you want to get one video from YouTube, you do like this. So I just copy and pasted the code that Google gave me. So even if you don't understand most of it, this is fine. You trust Google because they know better than you how to access their data, and this is how they want you to access it. So you just trust them at the moment. So HTTP error, it says the data API has not been used before or it is disabled. And so it gives me a warning, it gives me an error. It says, okay, you are connected, but maybe there is something that I have not enabled. So I am, even if they give me the keys, I'm not really using them properly. There's something that I need to tweak, some settings that I need to change. And it's going to tell me, enable it by visiting this. And it says, if you enabled the API recently, wait a few minutes for the action to propagate, blah, blah, blah. So it says, I give you the keys, but I didn't tell my, the guy at the door that you have the keys. So even if you have the keys, he'll frown and says, oh, who are you? Why are you trying to get in this building? So there is no way of knowing which one it is. So let's try and see. Okay, it says here that some additional thing is required. So I do request permission. And I say, okay, a test for the YADESA Winter School. Okay, I get it. So the reason why I'm seeing this is because I created the app with my personal email, but on Colab I'm logged in as my institutional email. So they think I'm a different person. Okay, Google says, I gave this key to an individual, and now an organization wants to get in with the same key. Did they steal it? Do they have the rights? So that's the problem. How to solve it? Probably if I just go with my personal account on the same notebook, it should work. Okay. Need to execute. Tight on time. Still a problem. Let's see. Something is wrong here. Credentials. Let's try this. Okay, now it works. So if it doesn't work on your machine, you either have to wait or you have to tinker with the Google console, developer console thing. So it's not important that it works right now. The important thing, like other platforms have easier ways of accessing it. But basically now, all this code that you see here, I copied and pasted from some Google documentation. So Google tells me to find multiple videos. I put my IDs in a list of IDs. I do join, which joins what basically converts this to a unique string. And then I say, get my items, get my things, get the videos that I want. Execute the query, and then I say, I found these videos, 2 videos, 4V in videos, blah, blah, blah. What's trending? So the popular videos right now, same scenario. You don't need to understand the code. You just need to trust Google that this code works. Searching for videos, how to maybe search videos that have some characteristics, some text. Get channels. So a channel is a collection of videos. Is an account on YouTube that posts this video. Playlists. You give a channel ID, you get the playlist ID, and then you go through the playlist to see all the videos. Comments. You give a video, you have a video ID, and then you say, okay, for all the comments that you do, that you see, print some statistics, some data about it. It's always like this. The LLMs, particularly Claude and Gemini, because this is a Google product, they know very well how these things work. So if it doesn't work, you can totally ask them and they will know how to fix it. And finally, so this is very crucial. So please pay attention to this point. The code that you execute on Google Colab is not, and the files that you're using, they are not physically on your machine. They are on a computer in some server in Google. Okay, Google headquarters. What this means is I'm collecting data using Colab, but I'm not saving the data to my computer. I'm saving it to Google's computer. And if Google kicks me out, I lose the data that I collected. So, 2 options. First, there is an equivalent of Google Colab that works on your computer. You don't need to worry about that for this winter school, but it's very easy. Online tutorials, click 2 things, install, and it works exactly the same structure, same things inside. The second thing you can do is after you've collected the data, if you're using a Colab, you go to the file inspector. Let's say I've collected this folder, and you can just do, not here, but there is a way of saying like, save this. Scarica. Scarica means download, sorry. So there is a way of saying, okay, download this. Remember, if you don't download this data from Colab, it stays on Google machine, and then it's lost once it kicks you out. So for a small project like this, it's fine to use Google Colab. For very large data collection that takes maybe weeks or months, you want to move to your own local machine, to a computer that can save data, that has enough space, and that is always plugged into the electricity socket. About your project. Now we will briefly see other APIs, but about your project. If I were you, I would work like this. So getting data takes time, doesn't always work the way you want, and I understand that the time is very tight, okay? What you can do is you divide each group into 2 teams. That is just my suggestion. So one team tries to make the API work or make the web scraping work. They try to tinker it, ask ChatGPT, ask Claude, try to make something work, to have some minimum working example of how to collect the data. If you don't manage to do that, so another team, what they can do is just to have some minimum working example, some minimal text to be analyzed in the next sessions, is just copy and paste physically a few text. I would say 5 text is fine. Okay, it depends on your research question though. So someone please try to work with it. If it takes too much time, if you don't manage to make it work, first of all, talk to us, ask questions. Some of you have my email. If it doesn't work anyway, and you need to go further with the things you see tomorrow and the day after, you need some text. And instead of thinking of another research question, blah, blah, blah, it would be great if you could collect that manually just for the time being. And then maybe after the winter school, you can email us again and say, okay, now I want to really work on that and I really want to do that project. How can I do that? I will be very happy to help. But just so that you don't stress too much over the complex code, the API, blah, blah, blah things. Okay, problems with that? Go on.
Can you make one real example from either YouTube or Blue Sky that you extract data and we can see it?
Yes, but this is exactly this.
So let's look at a YouTube page or...
Okay, let's go to a real YouTube video.
Yes.
Okay, so the way I would do it is I would go to, sorry, this is my wife's YouTube actually. No, it's my one. It's my one. Sorry. So let's go with this one. Don't judge me for my tastes. So this is the YouTube video that I want. I take the URL, right? And
Sorry.
Yes.
But let's have a research question, and based on that research question, let's target a specific data that...
Okay. Sure. So a good research question would be, I take a video from a news source, I take a video of a same thing from another news source, and I compare the comments. So the same news, with different videos, same topic, is the sentiment on one side better or higher or lower than the sentiment on the other side? So this involves a bit of text analysis, which we won't do today. But the idea is basically, we go to YouTube, we ask like climate change. So, can you fix climate change? This is one of the videos we could look at.
So in that case, how do we extract the comment?
How to extract a comment from a YouTube video?
Yeah.
Let's do it very quickly. So I left for you in the notebook, I left information on how to do it, like the code that Google gives you to do it.
Okay.
So this is you need a video ID. So again, I have this YouTube video here. So what I can do is take the last part after the equal sign. This is my video ID. I put it here. Then this is some Google magic that tells YouTube, get this video. And then it automatically does that for you. Like for seeing comments, it iterates over the comments and says, looks at the data, text, and author. So we say that, so it prints it that way. This guy says, you want to learn more about science, this is an ad, okay? This guy says, this video is generally very honest and blah, blah, blah, blah.
So now upload, how do we clean it and use it?
That's a topic for tomorrow's lesson. But what you will do, what you would do now is find a way to save it somewhere. Because now we are printing it on the screen. What you want is actually to save it to some file. What you can do is add a new line of code and ask Gemini, save comments on a CSV file. CSV means comma separated value, which is it's like an Excel. Gemini will do that for you, and then you download the CSV file into your own. Exactly. Accept. Okay. So I saved the comments in my comments.csv. So if I want to, so this is not already in my machine, this is online. So what I can do is take here and click download, the first thing that pops up. And you see it's downloading my comments here. So to open it, I click on it, and now it is on my machine. Okay, so we can see that it said author and comments. It didn't say, for instance, the time exactly. Sorry about that. The timestamp where this, but there is information inside the comments that you asked from Google, and there is a way actually of doing that. So I think we're a bit strict on tight on time. Let me show you something very quick. Where is it? Okay, very quickly. So this is YouTube. Some of you want to use Reddit. There is the same process, slightly simpler, is explained here in this Reddit./Blue Sky things. Very simple, and the documentation on what you can do with it is online as well. There is another option you have explicitly with Reddit. There is something called Arctic Shift. What does it do? So it is a website. Somebody downloaded all of Reddit, and they have it on their computer. And you can ask them to give you your data. So many researchers I know, but also people I don't know, what they do is they say they collect the data from the API, because this is technically obtained through the API of Reddit, while actually they take it from this guy. So
what was the name again?
it's I will put it in the thing in the notebook, but it's Arctic Shift.
He's selling, right?
No, it's free. He's one of the guys that try to advance the knowledge of the world with free data. So there is a download tool, and basically you say, okay, I want, R means subreddit. Subreddit is a forum about some topic. So I want r/Italy, where people talk about Italy. Start date, end date. I want to download the post or the comments or both. And then I just say start. And we'll do it. It takes some time. So what my advice, if you want to use Reddit for your project, a minimum viable example is take two communities. Maybe one is pro-Trump, the other one is anti-Trump. This is some research that we have done. You select the same time frame and say, okay, maybe a week. So during this week, maybe the election week, I don't know. The pro-Trump people use these words, the anti-Trump people use these other words. Okay, this is the easiest way to get data from Reddit. It takes a bit of time, especially if the data is large. So if you're all collecting all the subreddit, then it takes some time, but you can still do it, and it's perfectly fine to. So basically what happened was some researchers collected this data, and then Reddit said, okay, you collected it, you made it public, but now we are selling the APIs, so we don't want you to keep it accessed. So what they did, they moved to Russia. So now these servers are in Russia, and they can do anything about it, and now you can collect data from there, and they claim that is the official Reddit data, non-manipulated. So this is only for Reddit, unfortunately, but maybe if you're in...
If you click here on start, how long would it take for you?
So if it's just, so this is a very large subreddit, so it would take maybe a day, but maybe not a day, but maybe a few hours. Okay. But if I just say start date...
Check like for the last 2 days when it has been set.
Okay. What day is it today? What is it, 2026? Today is, sorry about that, 2:04. And no, the start date is, let's say 1, and the end date is now, start. So they want you to save it to my things, and so say save. I do here and say save, and now it's downloading. It gives you, so 2 days in just a few seconds.
But that's not 2 days, that's 1 month.
Well, 1 month? Oh, right. Again, tired, talking for 6 hours. But yeah, you can see it's actually pretty fast. Your 1 month of data in just a few, it's almost at half, now it's blocked, why? No, it's still going, okay. So this is something you can do. You can pause this and resume it later.
What's that exactly? Sorry, because I just lost track.
No problem. I will send it to you. It's Arctic Shift. If you just Google Reddit database something.
So that's the only way to get data from Reddit?
No, this is the easiest way without APIs. This is again very gray area. Okay, in the
with the API, is there a limit in the number of posts we can daily download from Reddit?
Very good question. So, depending on the platform has some things that it's called a rate limit. Rate limit means how many things the platform will give you every tot seconds, every X days or minutes or months. So the way they monetize is if you pay us money, we will give you higher rate limits. So, for instance, if you want to know what are Reddit API rate limits, Reddit API rate limits.
And for New York Times as well.
What?
For New York Times.
For New York Times, okay, then we will see. So you will find this some. So for instance, someone is asking here, is Reddit's API rate limit 100 or 60 requests per minute? That's because maybe Reddit will say, if you want posts, you can ask 60 posts per minute. If you want comments, 100 comments per minute. So depending on, it takes a bit of reading somehow, but it's definitely easier than the scraping thing. Because once you know what you're doing, once you know where to what platform and how the platform works with access requests, then it's a piece of cake. The code is already there. You copy it, you click it, and then you just wait. Very quickly, the New York Times. What was it?
Did it finish?
No, I paused it. But so sorry about that.
So the result will be a CSV file.
The result, it really depends. I think it's not a CSV file. I think it's a JSON file. JSON is you can read it as a Python dictionary. You can ask ChatGPT, hey, this is a part of my file. Copy the first 2 lines and say, can you help me read it in Python format? Something like that. So again, for the New York Times, you have to go to New York Times API, register, so create an account, get the API key, but it's way easier than Google. It's very clear, it's very big text. Okay, I did it yesterday. It's very, very easy. We will not do this today because I think we're almost out of time. I need some water, sorry about that. But as you can see, your API key. There is a developer portal of the New York Times. Create an account, create a new app, give it a name, and then enable some checkbox, which is what can this API do? Can I access article search? Can I access top stories and books and blah, blah, blah. And then there is this code here, again, that does exactly the same thing. It looks all the article search that are about SpaceX from start date to the...
SpaceX.
SpaceX, yeah, it's supposed to be a keyword, yes. All the articles about SpaceX, the company by Elon Musk that tries to go to Mars, I guess. Top stories with the section science, and you can print it. Bestseller lists, because there is an API for books as well. It's very popular, I think. Then I left some exercises, but this is just to have. Yesterday I discovered that the BBC gives you free access to their API. No need for registration. This is crazy, but this is the kind of things that governments do that we like, right? They have this free access thing. Again, there is a package you have to install, and then no API key needed. So you just go bbc.news.getnews in some bbc.language.english or something else. Again, why is the code written this way? What does it mean, bbc.language.english, blah, blah, blah? I don't know. You don't need to know. You just need to trust that BBC knows what they are talking about. They know that the code...
I think they have other languages also. Right?
Yes. You can...
BBC can also broadcast in Arabic and other languages.
Exactly. So...
You can determine which language...
How can I do? I do BBC News, Python, GitHub. GitHub means it's a place where you find code. Yes, exactly. So this is News API. Somewhere, maybe it's this one, BBC News API. Somewhere here, it explains how it works. You can find the documentation. And this is the actual code that makes it run. You see, here it's collecting data in Bengali, right? So again, the categories, it's telling you, okay, there are different categories. And then it's telling you that you can do the same thing in other languages, JavaScript, PHP, Ruby, or you can use requests. So requests is a very powerful package. I didn't want to show you this because I don't want you to get confused. It's better if you think that if you consider requests something for web scraping and APIs something for data collection, like properly structured data collection. But in principle, you can use requests to interact with APIs. It's something else that you can do, but you really don't need to worry about that. Most of the time, if something is wrong, GitHub is your friend, and you can go to issues and say, okay, I have an issue with this. Some very good computer scientists, kind-hearted, will help you out and maybe insult you, but most of the time they will help you out. Sorry if this was very confusing, but the underlying idea is using API is simpler than using web scraping. Web scraping, I should use it only for the cases where there is no API, or it is expensive, or something like that. In all other cases, if there is an API, maybe it will be slow. Maybe it will say, okay, it takes, you can download only one post per day. And that's never the case, but maybe you can only download 100 posts per day. That could be slow, but it's still better most of the time than using web scraping and going through the pages, logging in, blah, blah, blah, doing a lot of things. What else did I want to show you? Yeah, there is also a notebook, in case you're interested, there is a notebook on social network analysis, the network thing that I've showed you before. So if you think you collect the data from social media, you can collect who replies to who, right? I reply to a post by Sumeye. This connects us in a network, and this network can be used to estimate our political opinions, for instance, because if we talk about the same stuff, maybe they can label us with the same political opinion, or maybe make different assumptions, and you can see what's happening there. So again, this code is demonstrational only. Maybe tomorrow the API will change. APIs will change. Python libraries will change as well. So it's not given that this will work, but it's far more likely to work more than web scraping. So again, web scraping only for limit cases. It's not very clear if what I'm doing is 100% safe to publish or to what. I mean, if you collect, maybe you analyze 1,000 pages, you don't technically need to explain that you use web scraping. You could say that you collect that yourself. Some people do that. Some people actually, like I guess that before knowing about web scraping, some of you have read through or clicked and copy and pasted a lot of links and text from the links. So some people do that. I used to do that. But yeah, anything else is just read, check if there is an API, and then apply for it, and then install the package and follow the instructions. And that's it. So I got a bit lost, and I see that most of you are lost. So is everything okay? Is something unclear? Is there a question? Or in that case, please wave at me because my eyesight again. Great.
Yeah, so there's a question I have since a few minutes ago. This is very interesting, and it shows that we will reach real data, really existing data, to work with. The process might seem, complicated, and this actually is what had convinced many social scientists to go and work with generative AI to extract data.
Mm-hmm.
I've seen many researchers doing this, asking, very specific, very precise, making very precise prompts, and not going through any of this. How the result, according to me, this leads to many hallucinations sometimes, because I've seen AI bringing you data that does not exist. That's a huge problem.
Indeed.
Many false positives also, things that have the same name but they have nothing to do with that. And creating data like you are given a kind of a grid to apply or theoretical framework, and then it starts giving you the same data for all countries.
Oh yeah.
Like you're working on different countries, and then the problem does not exist in that country, but it creates, hallucinations.
I get it.
And it's very dangerous because many people are using the data, as such, but while it does not actually exist.
Mm.
So what do you think of this?
So that's an incredibly good point. I think, so LLMs, so the machines that are behind the ChatGPT, the model that is behind ChatGPT, is not a search engine. It does not search for information. It generates text. So I disagree with this definition, but some say these are stochastic parrots. So they repeat what the most probable token, most likely word would be after a string of sentence. What is the capital of Paris? What is the capital of France? It is Paris. So it is 100% likely, most likely that they will answer like that. So that's what an LLM does. So in most recent advancements, the LLM is paired with a series of tools like a calculator. LLMs are terrible at mathematics. They generate text. They cannot perform mathematical operations. So what they invented is, I connect an LLM with a calculator. I let the calculator do the work and give it back to the model so that it serves the answer, okay? So, but even in that case, using ChatGPT to generate code, if you can understand most of it, for me it's fine. Using it to look for information is borderline. Using it to write things that you did not prompt, that's 100% going to cause problem. Try asking ChatGPT something you know very well. If you ask that, the first 2, 3, 4 sentences will be exactly what you were thinking of. Maybe better than how you would say it. Then at some point it will screw up. At some point it will say something that maybe it's not wrong, but it's slightly imprecise. So my master's student is using a lot of ChatGPT to write her thesis, okay? And I don't have much against it because I assume and I know that the thoughts that are behind that are their own. She said to me, okay, I have this idea, I want to do it that way, and she's using LLM to maybe phrase it properly in English because she's not a native English speaker, or maybe she has problems writing, I don't know. But I can see that there are some patterns that are typical of ChatGPT, okay? So, the dashes, the bullet points, there are a lot of, And then sometimes it invents papers with my name that I never wrote, okay? So, in that case, so generating citations is very common. I would never use it to find a citation. There are very good programs, very good websites to do that. One I use very much is called Research Rabbit. Very cool website. I have to log in, but you upload there your favorite papers. It links them in a network, and it will tell you what are the most recent papers that are related to the things you have there. Or it will tell you in order chronologically, it will give you a timeline, it will give you, there are a lot of filters. I use it for finding new things to read, it's very useful. Research Rabbit, not sponsored, by the way, it's free. But yeah, to come back to your point, one thing is using ChatGPT or these models to generate some code that you can then verify and whose data then you analyze on your own. And the other thing is making ChatGPT generate the data. If I say, ChatGPT, give me this information, most likely they will give it to you even if they don't know. So yeah, try not to think of LLMs as search engines, but rather as assistants that not always they don't always have your best interests in mind, but at least they try to answer your queries in a way that is useful to you. Other questions? Okay, I don't see any questions. Oh no, there.
Like if I want to see YouTube comments, can I use Webscraping instead of API?
Yes, exactly. So if there is an API, can I still use web scraping? The answer is it depends. So most platforms that offer you an API, they will also say, okay, you cannot use web scraping because I have a way, I'm providing you a way to get the data and you have to access it that way. But you could still do it. But it's, in my opinion, it's so hard that it's not worth it to do it. Like getting the data with the API, it may be a bit slower, but it for sure it is more clean. Also, when you move through the pages with the web scraper, you say, okay, go to this page. If I open a YouTube, where is it? I don't see the pointer anymore. Okay. If I go to YouTube video, what I see is these comments here. At some point, they will have to load a new one, right? So this thing is not a new page. It's loading more comments. With the API, I don't need to worry about this. But if I were to scrape this page right now, I will not see all the comments. I will only see the first that load. That's a big problem. So there are more advanced scraping libraries. One of these is, I forgot about it. Exactly. One of these is Selenium. Sorry about that. So Selenium is an automation tool. What it means is it uses requests for you. So it's Selenium that uses requests, but it opens, it visits the things, and you can say, okay, click there, do this, or open this page, wait for 5 seconds, and then scroll down, scroll down, scroll down, scroll down, scroll down until you finish all the comments, and then get all the comments with the beautiful soup. Okay, so this is very advanced. So I guess that this is already a lot to take in. So I figured that would be very advanced. But there's another options you could try. So on asking GPT to do this with Selenium, so Selenium requires a lot of installing, using drivers, computer science nerdy stuff. So that's complicated. It takes some time. But it's definitely doable. If to come back to your question, again, if there is an option of an API, it is just way more convenient to use it than not using it. Other questions? No. Okay, great.
Are you okay helping to groups for?
Sure, of course.
Okay.
Yeah.
We can have a break for 15 minutes.
Yeah, that would be great.
Sure.
Yeah. Thank you very much.
It was a good presentation.
Thank you.
It was really hard.
We understood the general parts, but of course it was hard. I think it's enough for now.
Yeah,
we just did the parts which we could. I mean, we couldn't do more than that.
No, I get it, but I know.